In this full course, you will learn the basics of Python programming. I'm Bo Carnes with FreeCodeCamp.org. I've previously created one of the most popular JavaScript courses on YouTube, and I've created many Python tutorials. Now I've created this complete Python course for beginners. You don't need any previous programming experience to follow along, and all you need to code in Python is a web browser. In this course, I will teach you all the core aspects of the Python programming language, and I will simplify the more complex topics. Python is considered one of the most popular programming languages in the world, and it's only growing in popularity. Python excels in a wide variety of scenarios, such as shell scripting, task automation, and web development. And it's also the language of choice for data analysis and machine learning. But it can also adapt to create games and work with embedded devices. We're going to jump right into it, so you can start coding your first Python program as soon as possible. To get started quickly, we'll use Replit, which is an online IDE that allows users to code and run programs in a variety of different languages, all in a web browser. And later, I'll show you how to get Python set up on your local operating system. After the first project, I'll go into more detail about each of the main features of Python. This section is comprehensive and detailed. And in the final section, you will use what you've been learning to code a blackjack game with me guiding you every step of the way. Throughout the course, there will be a little repetition of some of the key Python programming concepts to make sure you have a deep understanding of the language. So, let's get started. We're going to start by creating a simple rock, paper, scissors game. And we'll start by going to Replit.com. Replit provided a grant that made this course possible, and Replit is going to make it super easy to get up and running really quickly. So you can either sign up or log in and create an account. I'm just going to use my Google account. Okay, now that you're logged into Replit, you can either just click the Create button or this plus button over here to create a new Replit. And I'll make sure to create a Python Replit. But you can see you can also select all sorts of different programming languages. Oh, these are just the ones that start with the word Python. But so there's tons of different programming languages you can select. But in this case, we are just going to use Python. And then I'll click Create REPL. Okay, so let me just kind of show off Replit a little bit. This is where we're going to create our Python code. I'm going to zoom in just a little bit. So we're going to write the code right here, and then we can see some output over on the right side. And then you can create different files over on the left side here. And then there's some other things like you can connect to version control, and if you have environment variables, we're not even going to be discussing those in this course. There's a debugger, you can connect to a database, and just some other things, but we're mainly going to just be using this main.py program to write our program, and we're going to see the results in the console. So I'm just going to close this files window so it's a little bigger here. I'm going to start off by showing you how to create a variable with Python. So this is a rock, paper, scissors game, and there's going to be a player is going to have a choice, and a computer is going to have a choice. So I'm going to create a variable called player choice, and I'm going to set that equal to rock. So let's look at a few components about this. This is the variable name, player choice. And you can see if we use an underscore, that's just kind of the convention for Python to use an underscore if you're going to have a space in the variable name. And we're going to assign it, that's what this equal sign, this is the assign operator, and we're going to assign it to a string. A string is just a word or a collection of characters like rock, and we're going to put quotation marks around it. Now we could have also used single quotes instead of double quotes. As long as you use the same quote on each side, that's what's important. So we've now created a variable called player choice and assigned it to rock. And now we can reference this variable later, and whenever we reference the variable called player choice, it's going to, the code is going to automatically replace that player choice with rock. So this is going to be a very interactive project. I hope you're following along. I hope you have already got Replit loaded up like this. Now throughout this project, I'm going to tell you what the next thing to do is, and I want you to try doing it yourself before you watch what I'm going to do. So periodically you'll want to pause the video based on what I say and try to implement what I say, before you come back to the video and watch me implement it and see if you've implemented the same way. So I'm just going to zoom in one more time, and this is the first thing I want you to do. See if you can make another variable on the next line. So you're going to press return or enter to go to the next line, and this variable should be called computer choice, and you should set it to equal paper. Okay, so you can pause the video and see if you can make a variable called computer choice and set it to equal paper. So here, it's pretty simple here. It's going to start simple, but it's going to get harder as we go. So computer choice equals paper. Okay, so like I said, it's starting simple, but it's going to get more complex as we go along. If you've done that, you've now written your first line of Python code in this course. Okay, now I'm going to talk about functions. A function is a set of code which only runs when it is called. So I'm going to show you how to put this code into a function. Now, one thing about Python is that indentation is very important. So after we define the name of a function, any line of code that's indented the same amount is considered within that function. So I'm going to create a new line of code at the top, and I'm going to call it get choices. Okay, so we define the function with def and get choices, and I'm going to select all these two lines of code at the same time and just press the tab key, and that's going to indent all of these the same amount. And you can see sometimes there'll be squiggly lines, and if you hover over something with squiggly lines, it will tell you something. In this case, it just says the local variable called player choice is assigned to but never used. That's not necessarily bad. It's just telling us that usually if you create a variable, you're going to want to use it later. Well, we are going to use it later. We just haven't gotten to it yet. So sometimes the squiggly lines will indicate there's some sort of error in the code. Usually, I think it's the color red will indicate an error. But if it's a different color, it just may mean that there's something maybe not quite right, but it's not really that big of a deal. So if you have a variable that's assigned to but never used, that's not going to stop your program, but it's just saying that this variable isn't really being used for anything yet. But we will change that. This function, I'm going to show you how to call a function later, but we're creating a function called getChoices that assigns these two variables, and it's also, I'm going to put another line at the very end here, and it's a return statement. And I'm going to return player choice. This will indicate what's returned when this function is called. So later we'll call this function getChoices, and it will return something. It will return the player choice, which is right here. It will return, in this case, rock that we can use somewhere else in our code. And I did just happen to put an extra line here. That's optional. I put a blank line here just to kind of make things easy, to kind of organize the code a little bit. So sometimes I'll just put an extra line between different sections of code, and it just makes it easier to identify the different sections when you're looking at the code. For the computer, those extra lines don't mean anything. The indentation, though, definitely does mean something. So as long as every line of code is indented the same amount as the previous line of code, then it's all within the same function. Okay, so this is what I want you to do. See if you can change the return statement. So instead of returning player choice, it's returning the computer choice. So that's pretty simple. It's now returning the computer choice here. Now I'm going to create another function down here. This is just going to be an example function just so I can demonstrate something to you, and then we'll delete it. It's not going to be part of our rock, paper, scissors game. But I'm going to create a new function called greeting. And then I am going to add what it's going to do. Oh yeah, put the semicolon. You also, or no, a colon. So a function always has to have a colon at the end of how we define it. So I'm going to return a string, and it's just going to say hi. And one thing you'll notice is that you don't have to put any anything at the end of each line. Some programming languages, such as JavaScript, you're going to put a semicolon at the end of a line. But in Python, it doesn't matter. You don't put anything at the end of each line. So now I'm going to call the function. To call the function, I just type the name and I put the parentheses at the end. So it's going to say, so greeting is now going to call, it's going to call this function, and that's going to return the string hi. Now, it's not going to do anything with the string because our program doesn't do anything with the string that's been returned. It's not going to go into the console or anything. But let's add additional code so we will make this string hi go onto the console. First, let me create a variable that takes what this greeting function returns. So I'm going to type in response equals greeting. So now we've set the what greeting is being returned to this variable called response. And now I can use the print function and I can print the response, and this will print it to the console. So now we have this green button here. This runs the program. I'll click this green button here, and now we can see it's hi. So this response is getting this hi from here, and then we're printing it right there. Okay, I'm actually going to delete all of this. And what I want you to try to do now is to call the getChoices function and store the response in a variable called choices, and then print the value of choices to the console. So you can pause and try that really quick, and then I'm going to show you how. Okay, so remember the variable is called choices, and we're going to set that equal to the getChoices variable. Now, or the getChoices function. Now, instead of typing out getChoices, you can see that this code editor is actually giving us suggestions on what we want to put in here. So I just typed in get, and you can see it's now saying getChoices right here. So I can actually, instead of typing out the whole thing, I can either click there, or I can just press the tab key, and it's going to fill in the rest of that function name. So that's just something little that makes it easier to write a program, and you don't have to type out every single thing. So if you've already created a function or a variable, then the code editor, then Replit will suggest what you may want to fill in when you're typing. And most other code editors do something similar. It's called code completion. So I'm going to, but I still have to add parentheses at the end. And now I'm going to print the choices. Okay, so I'm going to just click this play button to make sure it does what we're trying to do. Yep, it clicked paper. Great. Now let's talk about dictionaries. Dictionaries in Python are used to store data values in key value pairs. So let me just show you an example. Okay, so a dictionary is going to have these curly braces at the beginning and end, and then here's a key value pair. There's one, it's separated by a comma, and then here's another key value pair. So we're setting name, we're setting that to equal bow, and we're setting the color to equal blue. So here's the key, here's the value. Here's the key, here's the value. And the key, or the value in a dictionary, can be a variable. Like the color, we could set that. We already created this variable here. I'm just going to copy the word choices, and we can put choices. And you can see now it's not surrounded by the quotation marks. So if you surrounded by quotation marks, it's a string. But if we don't surround it by quotation marks, it's getting the variable here, choices. So this would be set to paper, because that's what choice is gonna equal. So we're about to delete this line because that was just an example. But now, before the return statement in this function, we're going to add a new line. We're going to create a variable named choices and make it equal to a dictionary. The first key should be player with a value of the player choice, actually this variable here. The second key should be computer with a value of computer choice. And then we're going to update the return statement to return the choices dictionary. Now, I'm not going to keep telling you to pause and try it yourself. So just the rest of this time, whenever I say what we're going to do, you'll know that after I get done explaining it, you can pause it and try it yourself. But that's what we're going to do now. So I'm going to create choices, and it's going to be a dictionary, and then it's going to have a player. That's the key, and the value is going to be player choice. And I was just able to press tab to fill that in. And then we're going to have computer, and it's going to be computer choice. And you can see sometimes if it goes to the next line, there just won't be a line number right here. But I can move this over for now. And then I am going to, oh, I forgot to put the equal sign. That's what that red squiggly line means. So, because the red means there is a problem in the program, so it's not going to run correctly. Now, the orange just means that we haven't used choices yet, which we will right now, because we're going to return choices. Choices. Okay, so now we don't have any squiggly lines because we're using every variable that we created, and we're returning choices here. So you may have noticed that player choice, it does not actually get set to the player's actual choice. So let's fix that. The input function gets input from a user, and we'll use it to get the player's choice. So instead of having player's choice equal rock, we're going to make player's choice input, enter a choice. Rock, paper, scissors. Okay, so this is how you get input from a user. We use the input function, and this is going to be something that's going to be printed. We'll print to the console here, and whatever the result of this input will be that the user entered will get stored to this variable, which we then can use later in our program. So let's just try that out. I'll click run and enter it. Let me just stop and run it again. Okay, enter a choice, rock, paper, scissors. I'll just put rock. And now you can see the player's choice, we're still printing that, and it's going to print as rock. Great, now let's just clean up this code a little bit. We still have this here, we don't need that dictionary, that's not going to be part of our final code. And now we'll make it so the computer can actually make a choice. So we're going to learn about importing libraries, creating lists, and calling methods. Python libraries are a set of useful functions, so you don't have to write code from scratch. When you import a library to your program, you get access to more features without writing additional code. With basic Python, it's challenging to get your program to do something randomly, but it's easy to choose something randomly using the random library. So let me show you how we can import the random library. Import statements are used to import libraries, and they're usually put at the top of a program. So I'm going to press enter a few times here to add some lines at the top, and I'm going to do import random. So now we've imported the random library. So we're going to use that random library soon, but now let's learn about lists. A list in Python is used to store multiple items in a single variable. Lists are surrounded by brackets, and each item is separated by a comma. So here's an example. I could create a variable called food and set it to this list. It's going to have 3 items: pizza, carrots, and eggs. So this is a list of strings. And then you can also get a random item from the list. We're going to use now, we've imported random, we can get a random item by using that random library. So I'm going to put dinner equals random.choice. And then I'm going to pass in the list here. So using the random library, we can call choice, and then we can pass in a list, and it's going to choose a random item from that list and set it to equal this dinner variable. So right now the computer choice always equals paper, but we want it to be a random choice between rock, scissors, and paper. So before the computer choice variable is created, we'll create a new variable called options and assign it to a list of the possible options, rock, paper, scissors. Then we'll set the computer choice variable to be a random choice of one of the items in the options list. Okay, I hope you already tried this now, but let me show you how that's going to work. We'll create options, and we'll set it equal to this list of rock, paper, scissors. And you can see the code editor will often pop up these boxes with more information about what we're doing to give us some help with what we're trying to do here. So we're going to set this computer choice to be random.choice food. Not food. I was looking at the food down there. This is going to be options. There we go. And let's just try running this program and seeing what happens. So I'm going to put rock, and then we see the computer chose scissor. It should be scissors. That's why we're testing it out. I guess I spelled that wrong. Okay, so scissors with an S. So now let me try running it again. And you can see it chose scissors, but if we run it enough time, now it's choosing paper because it's choosing it at random. Okay, that's working. Okay, so now let's just delete all this code after the getChoices function. We don't need to test that getChoices function anymore. And now let's create a new function called checkWhen. So you should know enough about how to create a function. So def checkWhen. So this is just an empty function with nothing inside it yet. But before we add, with the colon. So before we add any code inside the function, we're going to create some arguments. Functions can receive data when they're called. The data are called arguments. So when creating a function, you can specify arguments inside the parentheses. So we've been using this empty parentheses, but I can put in things within these parentheses. When this function is called, we're going to give it two pieces of data, or we're going to pass two pieces of data into the function. The first piece of data is going to be player. The second piece of data is going to be computer. So you can basically call these anything you want. These are just we're creating new variables, but when we call these functions, we'll pass in two pieces of information that will then be assigned to the variable names player and computer that we can use inside the function. So for now, let's finish off for a complete function. The function has to have some code within the function. So let's just add a return statement that's just going to return a list containing the elements player and computer. So this checkWhen function shouldn't actually return this. This is just to kind of get it quickly created. It should actually return different things depending on the player and computer arguments. An if statement will allow a program to do different things depending on certain conditions. So an if statement will first check a condition, and if the condition is true, then all the lines of code under the if statement that are indented the same amount will execute. So as a quick example, I can say A equals 3, B equals 5, and then we can create an if statement here. If A is greater than B, then we will do something like print yes. Or we can do if A is less than B, or we can do, if we want to check if A and B are equal, we can do we'll put two equal signs. Now this is very important. You never want to use one equal sign because a single equal sign is the assignment operator. That's how you assign what variables are equal to. So if you use a single equal sign, or if I put if A single equal sign B without a double equal sign, that is going to set A to equal B, which is not what we want. The double equal sign is going to check if A and B are the same value. Basically, it checks if two values are equal. Now, you can also do a not equal. So if you use the exclamation point, that's not equal. Or you can use less than or equal to, or you can do more than or equal to. So I'm just going to delete all this for now. So now we're going to update this return statement. Before the return statement, we're going to check if player equals computer. And if so, if true, we'll return the string it's a tie. So let's do that. If player equals computer, and this is something that maybe you figured out yourself before you're watching this, will return a string, and the string is going to be, it's a tie. Okay, so now it's only going to return, so a function does not have to return something. And for this function, it's only going to return something if this is true, if player equals computer. If not, it won't return anything. And just to make you notice this, see, this line is indented within the if statement, which is indented within this function. And just a really quick thing to note, for a return statement, parentheses are optional, so I could also add parentheses like that, but you don't need them. But for now, I'm just going to get rid of them. So currently, when there's a tie, the program now returns, it's a tie. But how does the player know that's true? Now let's have the program print which options that the player and the computer chose. You can concatenate strings with the plus operator. That just means you can combine strings with other strings or strings with variables. So let me show you how you can print which options were chosen. So I'm going to do print. You chose, and then I'll put player. So you chose, and then we have to add a space here because it's going to print a space, and then it will print this. So if the player chose rock, it will say you chose rock. And then we can so we concatenated these together, but we can add another plus sign and put another string here, and it's going to say computer chose. Oh, it's like being covered up here by everything. Computer chose. Now, I'm just about to type it in, but see if you can figure out what to add at the end here to put in what the computer chose. So computer chose computer, or the value of this variable here. So a lot of times with programming, there's a bunch of ways to do the same thing. So this is one way to combine strings and variables together. There's another way that's a little simpler called an F string. So an F string will allow you to mix strings with variables and other Python code. So to do that, you just put a variable, or you just put F at the beginning of a string. So let me just give you an example. So we do age equals 25. We're going to create a variable, and then I'm going to make an F string. We'll make it a print statement, and I'm going to put a string in here, but instead of starting with a quotation mark, it's going to start with an F. And then I'm going to put Jim is, and then whenever you want to put a variable or any kind of Python code, we're going to put some curly braces. And I'm just going to put the variable within the curly braces. So years old. And I'll put the end of the string, or let me put a period here. Okay, so Jim is age, which is going to be 25 years old. So the F string is just a slightly simpler way to combine the strings and the variables. So what I want you to do, see if you can figure out how to update this line right here so it uses an F string and it uses these curly braces instead of all these pluses up there. So yeah, we're going to put F, and I can delete a lot of these things here. And then I'm going to put some curly braces. You chose player. There we go. Okay, you chose, there was a comma right here. You chose player, computer chose computer. Okay, so now we've been able to put in the variable within this string with the F string. So we're going to test this out. So in a code, the code in this function never gets run. So when we press the run button, it's not going to run any of the code within the function unless the function is called within the program. So we're not going to test out this function all right now. What I want you to do is see if you can add a line to call the check when function, and then just call it with rock and paper. So we're going to just do check when rock, or actually we have to pass in strings here. Rock, paper. So this is it's going to call this function with rock instead of player and paper instead of computer. So let me try running this program. You chose rock, computer chose paper. And just don't worry about these little icons here. Sometimes they just block what's in there, but it's still behind that little search icon. So it's doing you chose rock, computer chose paper. Now let's get back to checking the winner. So far, this function is only going to check if there's a tie. Now we'll start adding code to check different win conditions. So let's learn about else and elif statements. Okay, so down here I'm just going to paste an example. So here's the if statement. If age is greater than or equal to 18, it's going to print this. Else, so anytime this is not true, then it's going to print you are a child. Okay, now here I've combined it with something else. The elif statement. Elif just stands for else if. It combines else and if, so you have to put a condition. So if age is greater than or equal to 18, print you are an adult. Else if, now we're going to check if age is greater than 12, you are a teenager. Else if age is greater than 1, print you are a child. Or else if none of these other things are true, we'll just print you are a baby. So, and it's only going to do one of these. It's going to get to once it gets to the first one that's true, then it's not going to check the rest. It's just going to kind of go to the next line of code after all these statements. So it's just going to choose one, and then once it gets to the first one that's true, then it's going to be done with this whole section of code. You can also check for two conditions at once. Let me give you an example. I'm just going to delete all this code, and I'm going to create an elif statement here. Elif, else if, and we're going to check if player is equal to rock, and I'm just going to type in the word and computer is equal to scissors. So now I'm checking if both these conditions have to be true. So this condition and this condition have to be true before the following statement will happen, which we're going to just put return rock smashes scissors. You win. Okay, now the next thing we're going to do, let's see if you can figure out how to do this. We're going to add another elif statement, and this time we'll check if player is equal to rock and computer is equal to paper. And if so, we'll return paper covers rock, you lose. So we're going to make this kind of easier by just copying this code, and then I'm just going to paste in this, and then I'll just change this. So players equal to rock, and computer is equal to paper instead of scissors. Paper. And it's going to say paper covers rock. You lose. And we won't even have an exclamation point anymore because it's not exciting to lose. Okay, and you can kind of see we could add a few more elif statements to cover all the different situations. But instead, we're going to talk about refactoring. Refactoring is the process of restructuring code while keeping the original functionality. When creating a program, it's common to refactor code to make it simpler or more understandable. So we are actually going to refactor this code that I've highlighted now, and we are going to instead use a nested if statement. A nested if statement will make the code more understandable at a quick glance. So you can put an if statement inside another if, else, or elif statement. So you'll notice here, the first elif statement is if player equals rock, and the second elif statement is if player equals rock. So see if you can figure out how to refactor this to not have to use the and anymore. We're just going to use one if statement, and one elif statement, and then an if statement under that elif statement. If that doesn't make sense, you can just see what I do right now. So I'm going to just move this down a little bit. I'm going to actually copy and paste some of these items, but we're going to start with L if player equals rock. We're not going to have this. I'm going to put this on a new line and say if computer equals scissors. So first we're going to check if player equals rock, and then if so, we're then going to check, it's going to be a nested if statement, if computer equals scissors. And if computer equals scissors, then we're going to use this return statement here. So I have to make sure it's indented correctly. It's going to, so this is what we have player, if player equals rock, then if computer equals scissors, we'll return, oh, this needs to be indented one more time to be inside that if statement. And now we don't even need this elif statement. This can just be an else statement. Else, because if the computer equals scissors, there's only one other option, because we already know if player equals rock and computer equals rock, we'll have already returned it's a tie. And by the way, once you return something, the rest of the code in a function does not run. So if we're returning it's a tie, nothing else after that is going to run. So we know that computer can't equal the rock at this point. So it's either going to be scissors or paper. So we don't even have to check if computer equals paper, because at this point, computer has to equals paper. And then we'll just return this line. Let's see. There we go. Return paper covers rock. You lose. So now we just basically have to add two more sections similar to this. So this one is if player equals rock. Then we have to have another section if player equals paper. And then if player equals scissors. And then we just have to have the stuff inside is going to be pretty similar, just corresponding to the different relationships between rock, paper, scissors. So I'm just going to copy that, and then I will paste it here. And then one thing important, you have to make sure this elif statement lines up with this elif statement. And this is now going to be paper. And then we are going to check if computer equals rock. And if computer equals rock, then we will say that paper covers rock. You win. Or we'll say scissors cuts paper. You lose. And then the final one, which at this point I'm sure you can figure out on your own, we're going to add one more section, and if player equals scissors. And then first we're going to check if computer equals paper. If so, we will do scissors cuts paper. We're just making it so every time the first one is you win and the second one is you lose. But you could do it the other way around. And then we will do rock smashes scissors. You lose. Okay, we're almost finished with this whole program. So both the getChoices function and the checkWin function, they're both complete. Now we'll add code to call the functions and play the game. So first, let's remove this checkWin. Now we'll create a variable called choices and make it equal to the result of calling the getChoices function. And we just have to make sure it's not indented. It's on the first column, or I guess right here, not indented at all. So we'll do choices equals getChoices. And one thing about this is it's going to return a dictionary. So if we look at the getChoices, so it's returning choices, and it's going to be a dictionary like this. Now, let me just copy this. I'm going to show you something down here. I'm going to just paste it down here, and we'll just make it an example of what it could look like. It could look like rock and paper. I always use rock and paper as examples because scissors is a little harder for me to spell. so that's a little easier. So one thing we haven't talked about is how to access a specific element within a dictionary. So this is a dictionary. So let's say if I call this well, I'll just call it choices, even because we're going to delete that, and so we're only going to have this choices. But if choices equals this, and let's say I just want to get the choice of the player, let me show you how I would do that. I'll just do pchoice for player choice, and I'm going to put equal choices, and to get just the value of the player, I'm going to put brackets. So the brackets look like that, and then I have to put the key that I want the value of. So the key would be player. So if I put the name of the dictionary, which is this, and then I put some brackets, we're going to use brackets to identify what is the key that we want the value of. So here's the key with the value of rock, and here's a key with a value of paper. So this is how we can get the player choice, and I'm sure you can see how you get the computer choice. Is if we take this computer word and put it right here, computer. Okay, I'm just going to get rid of all this here, and we have the get choices here. And now listen carefully to what we're going to do next. We are going to create a variable called result and make it equal to the result of calling the check win function. And when we call the check win function, we're going to pass in the value of the player key and the computer key of the choices dictionary. So let's do that. So then you'll see what I mean. Result is going to be, we're going to call check win, and then we are going to pass in, we have choices player and choices computer. So, because remember I showed the example of that dictionary. So we're getting the player key, the value of the player key, and the value of the computer key. So now we know who wins. This result variable is going to be one of these strings that have been returned. Either it's a tie, rocks versus scissors, paper covers rocks, and so on. So now we just have to print the result. We're going to print the result. Okay, we can try out this game. I'm going to just click the run button. Okay, this is why it's sometimes better to test a little earlier. I just forgot the semicolon on some of these. So semicolon, and see there's that red arrow. I should have seen that semicolon and semicolon. Okay, now let's try it. I'm going to play the program, enter a choice. I'm going to do rock. And I just noticed something else I want to change. So enter a choice. Yeah, there's a parenthesis here. There's no parentheses at the end. So again, I'm just going to change that really quick. So enter a choice, and we're going to put it in parentheses here, and test it again. So rock. Okay, you chose rock. Computer chose rock. It's a tie. Okay, I'm going to play it again. Paper. You chose paper. Computer chose scissors. Scissors cuts paper. You lose. Okay, we just created a Python game. So hopefully this gives you a better understanding of what it's like to program in Python, and you now know about some of the basic concepts of Python. Now there's a lot more to learn in Python, and we're going to be covering a lot more in this course. I just wanted to start with a game and a full program, so just right off the bat you could code a program. So in the next section, I'm going to start going over in detail all the most common features of Python. And we're going to cover some of the features that we've already used in this game, plus a lot of additional features, additional common features that were not used in this game. And then in the final section of the course, we're going to code a more complex game, a blackjack game. So let's get started with the next section. One of the quickest and easiest ways to get started with Python is by using Replit.com. But you may also want to get Python running on your local computer. So if you want to do that, you can start by going over to python.org, and then you just go to the downloads menu, and then you're going to just click what you want to download for. So it's going to default to be for you the operating system you're on, but you can also go to other platforms and make sure you can, and then just find the platform that you want to download on. And there's going to be instructions on here that's going to tell you how to go about getting installed on your specific computer. So there's a few different ways to run a Python programs. And one of the ways is with an interactive prompt. So after you get installed, if you open up your terminal and type in Python, or sometimes it's going to be Python 3, depending on how you got it installed, you're going to see this interactive prompt. And then you can just, this is called a Python REPL. It's different from a REPL created with Replit, but you can start coding in Python right on here. So I could say name equals Bo, and then you have to make sure you put the quotation marks at the end, and now I've gotten a variable stored as Bo, and then I can just type in the variable name, and it's going to show me the value of the variable. And you can type in most different Python commands right into this interactive prompt here, and then I can just quit it when I'm ready to quit. It's also common to run Python using Visual Studio Code. So if you just search for Visual Studio Code, you can get to the download page, and then you can just download it for your system. And there's also, you can download for different systems. And then once you open up Visual Studio Code, to get Python working, you're going to want to install the Python extension. So I'm going to click over here to extensions, and you can search for Python, or it may just be listed here under popular extensions. And I'm just going to click install. And this is going to make it easier to work with Python on Visual Studio Code. So now I can just kind of close some of this stuff here. And I'm going to create a new file, and I can just and I can just type in name equals Bo, print name, and then if I save this as test.py, it's going to add the colors that correspond to Python, and then I'm just going to click this play button here. And it's going to open up a terminal window here, and it's going to run the program, and it's going to print Bo. That's what my program did. If I zoom out a little bit, you'll be able to see the difference. So we just printed the name, and it runs the program just like that. And then you can see on the terminal how the command that was used to run that. So we could use the same command on any terminal. And instead of typing this whole thing for the location of Python 3, I could just do Python 3, and then this is where that file is located. So just copy that, and I can paste it in here, and it's going to run that program. In this section, we'll learn about the core features of Python. I'll go into more detail about some of the things we learned in the first project, and I'll be covering a lot more concepts. This section was heavily inspired by the Python Handbook by Flavio Copes, and you can check that out on FreeCodeCamp News. And like the first part of the course, I'll be writing Python in Replit. So once you get logged into Replit, just like I already showed you before, you can hit the plus button here or the create button to create a new Replit, and then you can search for the programming language, or you can just click it down here, Python. We'll just create a Python REPL. And then we can instantly start writing Python code in Replit. So, like I showed before, we got our different files here. We're just going to start by using one file here, and this is where you're going to code, and this is where it's going to appear if we run the code. So I'm going to close off the list of files here, and let's just start at the beginning again. So you've gotten used to coding in Python through creating a rock, paper, scissors game, but now we're going to kind of do a deep dive into all the basic commands of Python. So there's going to be some review, but we're going to be going into more detail about each of the elements. And the first thing we're going to talk about is variables. So we can create a new Python variable by assigning a value to a label using the equal sign or the assignment operator. So let me give you an example. Just like I was showing you before, just name equals Bo. So let me just zoom in a little bit more here. And so now our variable name is name, and we've assigned it the value of Bo. And then we can also create a variable with a number. So I could do age equals 39. So a variable name can be composed of characters, numbers, and an underscore character. And it cannot start with a number. So it could be anything like name 1. It could be all capital letters. It could it could have an underscore, it can start with an underscore like I said, like that. And you can see that these are all, it's putting these red squiggly lines because it's showing that that's not actual Python code. If you're going to create a variable, you should be assigning it to a value, or you should be using a variable that already exists. But I'm just showing you some different examples of different variables. Now, so here's an example of an invalid variable name. If you just start with a number like that, that can't be a variable because you can't start with a number. And I couldn't put something like test exclamation point. You can't use exclamation points. You can't use percent signs. And other than that, anything is valid unless it's a Python keyword. So there's some keywords. A keyword is something that's used to write Python, like for, if, while, import. These are all words that have very specific meanings within Python, so you cannot use them for a variable name. Now, there's no need to memorize them, as the Python editor here will alert you if you use one of those as a variable. So that was just like, if I say if equals hi, and then you can see it's going to show you right here with these squiggly lines that we've done something wrong. Invalid syntax, because, and then also you can see that it turns blue. This word turns blue because it's a keyword. You can't use it as a variable name. So like I said, it's going to alert you if you use a keyword as a variable, and you'll start to gradually recognize them as part of the Python programming language syntax. Now let's talk about expressions and statements in Python. So an expression is any sort of code that returns a value. Like for instance, if you do 1 + 1, or if you just do a string like bow, this is going to return 2. This is going to return the string bow. So a statement, on the other hand, is an operation on a value. So for example, this is a statement here because we have an operation. We're assigning this to the variable. And then another statement would be like this: print name. So that's going to be a statement because it's doing something to the value. Now, a program is formed by a series of statements, and each statement is put on its own line, like we have these two lines here, but you can use a semicolon to have more than one statement on a single line. So I could put a semicolon here, and then if I run the program, it's still going to print the name. And let's just do that. We already learned how to run a program in Replit, which is just to click this button right here, but we can see it's going to print bow, and if I put these on two different lines, it's going to do the same thing. If I run the program, it's going to still do the same thing here. Now let's talk about comments. This is something we haven't talked about in this course yet. So in the Python program, everything after a hash mark is ignored. So if I put a hash mark, I can say this is a commented line. And when we run the program, this line is going to be completely ignored. And then we can also put an inline comment. If I just put the hash mark here, this is an inline comment. And the cool thing about most code editors, including Replit, is it's going to put comments, it's going to make them gray. So you know that this isn't really part of the program. This is just some sort of special note that the programmer wants to put as part of the program. So I want to emphasize again how important indentation is. So it's very meaningful in Python. So you can't randomly indent things. Like you can't just press tab here to indent here, and how this is kind of lined up here, this is lined up here. You can see this red squiggly line says unexpected indent. So some other languages do not have meaningful white space, and indentation doesn't matter. But in Python, indentation matters. So in this case, if you try to run this program, we can run this, and we'll see an error right here showing up in red here. It says indentation error, unexpected indent, because indentation has a special meaning. So I can just unindent that here. Everything indented belongs to a block, like a control statement or a conditional block or a function or a class body, and we'll be talking more about those different blocks later. Now let's talk about data types. Python has several built-in types. So for instance, this is a string. So anything surrounded by quotation marks is a string. That's one data type. And you can check the type of a variable by using the type function. So I could say type, and then I'll put name. And to make sure to be able to see it in the console, I'm going to print what the type is here. And if I run the program, we'll see that the type is the class of str, which stands for string. And then we can test to see if something is a string by comparing it to str. So I could do equals equals str, and then if I run that, it's going to say true, because the type of name does equal a string. And then we can also use isInstance. So I'm going to, so if we, instead of doing type, we do isInstance, and then we have to pass it two things. So the first thing we're going to pass it, so we have the isInstance, we're passing it the name, that's this variable, and str, we're trying to see if name is an instance of a string. And if I run that, it should say true again. So we've been testing against the str class, the string class, but it works the same for other data types. So there are some data types around numbers. So an integer numbers are represented using the int class, or the int class, and floating point numbers or fractions are the type float. So I can say age equals 2, and then we can just check isInstance, and then I can pass in the age, and then I can pass in an int. So if I run that, we're going to see that I've done something wrong. Oh, I spelled that wrong. There we go. Okay, now I'm going to try this, and we'll see true, true. And I can also type in float, true, false. It's not a false, or it's not a float, because it doesn't have a decimal point. If I did 2.9, then it should show that it is a float because it has a decimal. So Python automatically detects the type from the value type. So it automatically knows this is a string, it automatically knows this is a float, but you can also create a variable of a specific type by using the class constructor, passing a value literal or a variable name. Like, for instance, we have this, and we check to see if this is a float, and it's saying false. But I can make it a float by typing in float and just putting the value into the float here. So we're going to make it a float. So now it's true, true. And you can do the same thing with strings or integers or the other data types. And you can also convert from one data type to another by using the class constructor. So that's basically what we did. We just converted this from an integer to a float, but I can also do something else. I can convert something from a string to an integer. So for instance, we'll just get rid of this one completely here, and we'll just use this one. So a string is anything in quotation marks. So if I do 20, age 20, and I test if this is an int, it's going to say false. It's not an int, so I'm printing whether it's an instance of an int. But I can convert this string into an integer by just doing int here. And this, let me run the program, and it says true. Another thing about this is you don't just have to pass in the actual data or the actual string. I can pass in a variable. So I can say number equals, and now I'm going to make it it says number, but it's actually a string. But I can pass in the number here, and then it's going to set that to age, and it's going to be true. So we create the string, we convert the string to an integer, and we tested that age is an integer. So when we do something like this is called casting. It's basically trying to extract an integer from this string. Of course, the conversion might not always work, depending on the value that's passed. So, for instance, if we write test here in the string instead of the 20, we may get an error. So let me just run this and see. Now we have an error. It says invalid literal for int with base 10 test. So we can't convert the string test to an integer. So Python does its best to do the conversion, but it doesn't always work. There are a few other types. So let me here are some other common types of types. So there's the type of complex for complex numbers, bool for booleans, list for lists, tuple for tuples, range for ranges, dict are dictionaries, and set is a type for sets. And we'll explore all of these soon. We'll go into more detail about all these different types of types. Well, now let's talk about operators. We've already seen one operator, that's this one, that's the assignment operator. But there's also arithmetic operators, comparison operators, logical operators, bitwise operators, and plus some interesting ones like is and in. So we're going to be going over a lot of those right now. So we talked about the assignment operator, which is used to assign a value to a variable or to assign a variable value to another variable. Now let's talk about arithmetic operators. It's just what you use to do mathematics. So here are the different arithmetic operators. So we have plus, 1 plus 1 equals 2, then minus, multiplication, division. We have remainder. So 4 divided by 3 equals 1, but there's a remainder of 1. We have exponents, 4 to the power of 2 is 16, and floor division. So floor division does a division problem and then just basically rounds down. So floor division does the division and rounds down to the nearest whole number. So actually this would be better seen if we do 5 divided by 2. 5 floor division divided by 2 is going to be 2. Normally it'd be 2.5, but floor division, it's rounding down to the nearest integer, the nearest whole number. And then also note that the minus can also be make something a negative number. So I could do 4 plus negative, or I mean 1 plus negative 1, and then that's just going to equal 0. And then the plus operator can also be used to concatenate string values. That's something we talked about earlier, but I could say scamp and then put a plus is a good dog. And then like if I print this out, I put the parentheses around it, and then we'll see the whole string here. Scamp is a good dog. That was the name of my first dog when I was a kid. So we can also combine these arithmetic operators with the assignment operator. Let me show you what I mean. So let me just get rid of this here, and I'm going to do age equals 8 and age plus equals 8. And I'll do print age. So all these different operators can be combined with the assignment operator, and now it's going to add 8 to the age. So if I run this, it's 16. So this actually just means age equals age plus 8. So this age plus equals 8 is the same as saying age equals age plus 8. So it's just going to add this number to the current age and set it equal to the age. And you can do that with any of these. Like I could do times, and that would be age equals age times 8, and 64, and so on with any of these arithmetic operators. Okay, now let's talk about comparison operators. Now, we talked a little bit about them before, but let's see some examples again. So this is to compare if two things are equal, and then we have not equal. We're comparing them to see if they're not equal. This is if A is greater than B or more than B, and then this is less than or equal to B. Now let me just tell you a trick of how I keep track of which one is greater than and which one is less than. If you see this less than one, if you kind of tilt your head a little bit, it kind of looks like an L. See, like L. And this one doesn't look like as much of an L. So this less than operator kind of in some ways looks like a capital L that's kind of just squished over. And that's how I keep track of which one is less than and which one is greater than. And so these are all going to give either a false value or a true values. Speaking of true and false are examples of Boolean, the Boolean data type. The Boolean data type just means true, false, or true. So a Boolean is either going to be true or false. There's only two options. And there are a few Boolean operators. So let me show you what the Boolean operators are either not, and, or. So when working with true or false attributes, those work like logical and, or, and not. So when you're using not, it means it's not true. You're checking to see if something is not true. And means they both have to be true. And or means either this one has to be true or this one has to be true in order for the full thing to be evaluated as true. And let me show you something about or. Now, or, used in an expression, returns the value of the first operand that is not a false value or a falsy value. Otherwise, it returns the last operand. So it's going to return the first operand that is not a falsy value, but since this is a false value, it's returning the second operand. Since this is a false value, it returns the second one. Since this is not a false value, it will return the first one. And this is considered a falsy value. If it's just an empty bracket, that's false. So it's going to return the second value, which just happens to be false. And since this is a false value, it's going to return the second option, which also happens to equal to false. So one way to think about it for the word or is, this is how the Python docs describe it. If x is false, then y, else x. So this would be like x, this would be y. If else is false, then y, else x. And then for and down here, let's look at some examples for and. And only evaluates the second argument if the first one is true. So if the first argument is falsy, such as false, 0, an empty string, empty brackets, it returns that argument. Otherwise, it evaluates the second argument. So the way the Python docs describe it is, if x is false, then x, else y. Okay, let's quickly discuss bitwise operators. They're very rarely used, only in very specific situations, but it's worth knowing what these bitwise operators are, just in case you're in the very rare situation that you need to use them. And then two other types of operators are is and in. Now, is called the identity operator. It's used to compare two objects and returns true if both are the same objects. If both are the same object. And I'll be talking more about that later in the section on objects. And then in is called the membership operator. This is used to tell if a value is contained in a list or another sequence. And we'll be talking more about the in operator when we're discussing lists and other sequences later in this course. And the final thing I want to talk to you about is the ternary operator. Now, the ternary operator in Python allows you to quickly define a conditional. So here will be like kind of the slow way to do it without a ternary operator. So let's say you have a function that, in this function, is comparing age with 18, and it's going to return true or false depending on the result. So instead of writing it like this, we can implement it with a ternary operator. So let's do def is adult. I'll just call it is adult 2 because it's the second way of doing it. And this time we're going to use the ternary operator. It's just going to be return true if age is greater than 18, else false. So you can see first we define the result if the condition is true, then we evaluate the condition, and then we define the result if the condition is false. It's basically an if-else statement all on a single line. Okay, let's talk more about strings in Python. So a string in Python is a series of characters enclosed in quotes, in double quotes, or it could be single quotes, as long as the type of quote is the same on both sides. And we already talked about how you can assign a string to a variable. And we already talked about how you can concatenate two strings using the plus operator, like phrase equals bow, and then you can concatenate with the plus operator is my name. And then, well, also, instead of putting a string here, you can put the variable. So I could put name is my name, and we already have the variable here to equal bow. So when you're concatenating, you can concatenate the strings or the variables. You can also append to a string using the plus equal operator. So let's say I want to add to this name, and I'm going to say name plus equals is my name. So we're adding is my name to the end of this. So I can say print name. And then we can see what it looks like when you use the plus equal operator. So Bo is my name. And then we already talked about how you can convert a number to a string using the str class constructor. Like if we had age equals, we could make this a string. But we pass this integer, it converts to a string, and now it's going to be a string. Now here's something new. A string can be multi-line when defined with a special syntax. So if you enclose the string in a set of 3 quotes. So let me show you an example. We'll get rid of all this, and I'm going to print an entire string here. So we're going to make this a multi-line string. I'm going to put 3 quotation marks, and then it's going to start with 3 quotation marks and end with 3 quotation marks. And then I can make it multi-line. So I can say Bo is, and then I can put some extra lines. 39 years old. Now if I print that, and you can see it's going to print the different lines here. So we just made a multi-line string. And you can also, instead of using the double quotes, you can put a single quote, as long as they're the same at the beginning and ending. Now a string also has a set of built-in methods. Well, let me show you an example. So if I have this string, Bo, but I'm going to put at the end of the string, I'm going to put dot upper. And I put parentheses at the end. So if I run this, now it's going to print it in all capital letters. And the same thing you can use with lower. So if I had a string that had a few capital letters, okay, now it's all lower. Now I can also type in a title, and this is going to make each so I can say Bo person, and I do this. So it's going to a title is going to make the first letter of each string a capital letter. I can also check things, like I can say is lower, and it's going to check if it's all lowercase letters. False. But if I make it so it is all lowercase letters, it's going to say true. So here's just a list of a few common ones. You can do is alpha to check if it contains only characters, is alnum to check if a string contains characters or digits and is not empty, is decimal, lower to make it lowercase, is lower, upper is upper, title starts with to check if it starts with a specific substring, to check if it ends with. You can replace part of a string, split a string, you can strip the white space from a string. You can append new letters to a string. You can find the position of a substring, and there's a few more, but these are some of the most common things you can do with a string. And then one thing to know about these is that they all return a new modified string. They don't actually alter the original string. So let me show you what I mean by that. So let's say we'll do name equals Beau again. Let me zoom in a little bit. And we're going to print name.lower. Now I'm going to print name. So if I just run this, and we first figure out what went wrong here. It looks like there's a few extra parentheses. Okay, let's run this. And you can see it's going to make it all lowercase, but then when I print the name again, it's not still lowercase, because this just returns a brand new modified string. It doesn't actually change anything in the original string. And then you can use some global functions with strings as well. So one function we haven't discussed yet is the len function, which stands for length. It can give the length of a string. So I'm going to type in len, and then so there's just some global functions that work with a lot of different types of data, and the length of this is 4, you can see. And then you can use the in operator. Now, I briefly mentioned the in operator earlier. So let me show you one use case. So we can use the in operator to check if a string contains a substring. Like, for instance, I can say AU in name. So let's check if name contains the letters AU. Well, true. It does, but if it didn't, if I just add an extra string, it's going to say false. Okay, another thing with strings, escaping is a way to add special characters into a string. For example, let's say we wanted to add a double quote within the string. How can I add a double quote into a string that's wrapped in double quotes? If I put a double quote like that, that's not going to work, because this is going to be the string, and then it's not going to, the code editor is not going to know what to do with this last little bit here. So the way to go is to escape the double quote inside the string with the backslash character. So right before this quote, I'm going to put the backslash character. And then you can see it now is all the same color as a string. And if I print it, it's not going to print the backslash character. So putting a backslash is how you escape a character, and that just means the backslash character means that the next character is not going to mean what it normally means. It's going to actually just be the string of that character. And you can do the same thing in this particular example, you may not need to do it, because you can always just put a single quote at the beginning and ending. And as long as you have a different type of quote at the beginning and ending, then you can put a double quote in the middle. But let's say you want a string that contains both a single quote and a double quote within the string. Then you will have to backslash. Like if I just put a single quote there, it's going to mess it up. But if I put a backslash, now it's going to have the double quote and the single quote right within the string. And you can also use the escape character for special formatting characters. Like, for instance, what if I wanted there to be a new line between the first two and the last two letters of the string? If I do /n, that is going to not actually just put a /n. Let's see what happens when I put that. This means new line. You can see it says BE, new line, AU. And then another a reason why you may want to use an escape character. Like, let's see what happens if I do this. That's not looking how I want to look, because it's normally when the code is running, if it sees this backslash, it thinks it's an escape character. So if you want to actually add a backslash to a string, you have to escape the backslash. So now it's BE backslash AU. Okay, we're done talking about escape characters. Now I'm going to tell you how you can get a specific character in a string. So given a string, you can get its character using square brackets to get a specific item, given its index starting from 0. So one thing to know about programming is that whenever you're counting in most programming languages, you start counting starting at 0. So this is going to get the letter at index 1. So this is index 0, the B. The E is at index 1, index 2, index 3. So if I run that, we can see we are getting the E that's at index 1. If I want to get the B, I just put a 0 in the brackets, and we get the B. And then we can use a negative number to start counting at the end. So if I put negative 1, it's going to start here, 0, 1, and that's going to be A. Oh, U. Okay, I guess when it's going backwards, it's not going to start 0 because there is no negative 0. That makes sense. So negative 1 is going to be the last character in the string. So negative 1, negative 2, negative 3, and so on. We can also use a range using what we call slicing. So if I put 1:2, this is going to be every character starting at index 1 and ending before index 2. So it starts at index 1, so it starts with that character, and it ends before index 2, which is A. So that's actually only going to return an E. But if I put 3 here, now we can return AU, and if I put Bo is cool, we can put one further down. I'm going to put 7, and we can see it's going to return part of this string. And then you can also start, if you just put a blank before the colon, then it's going to return everything up to, it's going to start at the beginning and return everything up to character 7. And you can also do it in the opposite direction. So if I put a blank after the colon, it's going to go to the end of the string. So it's going to say is cool. So let's talk about Booleans. Well, we already talked about Booleans, but we're going to talk a little bit more about Boolean, which is considered the bool type. And this can have two values, true or false. So I can say done equals true, or you can do done equals false. Now, notice that it always has a capital T or a capital F. So if you don't put a capital T or a capital F, it won't be considered the true Boolean value in Python. And Booleans can be especially useful with the conditional control structures like if statements. We already discussed if statements in the first part of the course, and we'll be discussing them more in detail later. But let me just show you an example. So if done, and I'm going to erase this done because we want it to be true. So if done, and then we'll say print yes, else print no. Okay, so I can run that, and it's going to print yes, because done equals true. But if done equals false, then it's just going to say no. So when evaluating a value for true or false, if the value is not a bool or Boolean, like if it's not true or false, we have some rules depending on the type we're checking. So numbers are always true except for the number 0. Like if I put 0 here, it's going to evaluate to false. But if I put any other number here, it's going to be true. Even like -1 or anything like that, it's going to be true. Oh, I guess that I didn't put -1, I put =1. So if it's -1, that's going to be true. So strings are always false. Oh, strings are false only when empty. So if I say bow here, this is going to be true because it's not an empty string. But if I make an empty string, then it's going to be false. Lists, tuples, and sets, and dictionaries, which we'll talk about more later, are false only when empty. So it's going to be, if a list, tuple, set, or dictionary is filled with something, then it's true. And then also you can check if a value is a Boolean. So if I say done equals true, I can do print type. We're going to check the type. We're going to check if the type of done equals bool. So let's check it. Does that equal Boolean? True, it does. Now let's change this to a different type, and it's going to say false. So it can still evaluate whether this is true or false, but the type is not a Boolean. The type is a string. And let me show you another example code. So the any function, it's a global function. It's very useful when working with Booleans. It returns true if any of the values of the iterable, such as a list, if any of them are true, it's going to return true for all of them. So, for instance, book 1 read, that's true, but book 2 read, that's false. But this is going to return true because it's checking if any of them are true, and then it's going to set this to true. Now the all function is similar, but returns true if all of the values are true. So we have this value as true, we have this value as false, whereas any would have returned true. This is going to return false because it only returns true if all of the values are true. Okay, now let's talk about more number data types. We already talked about int, an integer, a whole number. We've already talked about float, which is any number with a decimal point. There's another type called complex. Complex numbers are an extension of the familiar real number system in which all numbers are expressed as a sum of a real part and an imaginary part. Imaginary numbers are real multiples of the imaginary unit, which is the square root of -1, often written I in mathematics or J in engineering. Python has built-in support for complex numbers, which are written with the J notation. So the imaginary part is written with a J suffix. So you can combine it. You can use a literal value like complex equals 2 plus 3J. So the J means it's the imaginary part of the number. Or you can use the complex constructor. So I can put num equals complex, and then I'm going to pass in 2, 3. So the 3 part is the imaginary part. The 2 is the real part, the integer part. And then once you have a complex number, you can get its real or imaginary part like this. So I can say print num dot real or num dot imag. So this is going to be the 2, this is going to be the 3. So if I just I think the problem was num1, so I'll do num1 and num2, and we're going to do this as num2. Okay, let's check this. So this is the real part, this is the imaginary part, and you can see they're being returned as floats. And you can use the type function to check the type. So now let's talk about some built-in functions that help with numbers. So one of them is ABS. ABS will return the absolute value of a number. So if I say 5.5, that's just going to be 5.5. But if I put negative 5.5, well, it will be 5.5. So if I print this, see, 5.5, basically it just makes it so it's not negative. Then you can also use round. So if we do round, let's make this just 5.5. Round is going to round to the nearest integer. So if I do this, it's just going to be 6, so 0.5 is going to round up. But if we did 49, it's going to go down to 5. You can also specify a second parameter to set the decimal points precision. So I can go to, if I do 1 here, and then I round it, it's going to, instead of rounding to the nearest integer, it's now going to round to the nearest 10th place value, or 1 decimal point. There's several other math utility functions and constants that are provided by the Math Standard Library. Like there's a math package, a CMath package, decimal package, fractions package that makes it easier to work with different types of numbers. We'll explore some of those more later on. Now let's talk about enums. Enums are readable names that are bound to a constant value. So to use enums, we're going to have to import enums from the enum standard library module. Like this, from enum, import enum. And now we'll be talking more about importing stuff from modules later. But once you import it, then we can initialize a new enum in this way. So do class state enum. And so we can have inactive equals 0 and active equals 1. So basically the word state, this can be any word we like. So we're setting basically a variable called state.inactive, which is going to equal 0, or state.active to equal 1. So you can reference, this is how you would reference it. You can do print state.active. And then if I just run that program, we'll see. Now you can see it's just going to return state.active instead of 1. So to actually get the value, you use state.active.value. And then we run that, and then we'll see 1 here. If we want to just return state.active, that value can be reached by the number assigned in the enum. So state, we can do 1, and if I print that, it's now going to say state.active. Same for using the square brackets notation. So I could do states, I'll do the square brackets and put active. If I print that, it's going to print state.active. So this is basically the only way to create constants in Python. Python has no way to enforce that a variable should be a constant, so some people will use enums to create a constant, and then nobody can reassign the value. So when we do state or state active dot value, so it's not going to be able to be reassigned. So basically there's 2 ways to do it. We can do this bracket notation, or we can go back to the other way, active. Now we can also list all the possible values for an enum. So our enum is called state, and we can now just print all the values. Oh, I actually did that wrong. It's supposed to be list. So this is going to list the values of the state. And we can see we have inactive 0 and active is 1. And we can also count them using the length function. So we're going to print the result of a length state, and that's just going to give us 2. Okay, let's talk more about user input. Now we already discussed it a little bit in our first program, but you can get user input by using the input function. So let's just get rid of all this, and we'll do age equals input, and we can say print your age is, and then we just can concatenate that with the variable age. And then also if you want to, so let's just do a quick test, and right now it's looking for the age right now. I can put 5, your age is 5. So there's 2 ways to make it say what is your age. We can do a print statement right before here and do what is your age, and then now we can put 4, your age is 4. Now you can also, instead of putting the print statement right before here, I'm going to copy this, delete that, and we can put it right in this input function, and then it'll still say what is your age, and I can put an age here. So one thing to really realize about this is that it gets the input at runtime, meaning the program will stop execution and will wait until the user types something and presses the enter key. You can also do more complex input processing and accept input at program invocation time, and we'll see how to do that later on. If you want to get the input when the program is run, that's going to work better for command line applications. Other kinds of applications will need a different way of accepting input. Let's look more at control statements. This is another thing we've already discussed earlier, but we're going to review it and look at it in a little more detail. So a control statement is like an if statement. So if condition, that's this variable here, equals true, then it's going to run everything in the block. A block is the part that is indented one level. Usually it's going to be either 4 or 2 spaces. In this case, it's 4 spaces. Sometimes it's 2 spaces. It doesn't matter. It could even be 1 space as long as it's the same, as long as every line of code is indented the same amount. So if I just run that, the condition was true. The block can be formed by a single line or multiple lines, and it ends whenever you move back to the previous indentation level. So, for instance, if once we are not indented, I can say print outside if. So then that's always going to it's always going to print this because it's not in that if statement. And then we have the if else statements, where the else is if this does not true, then it's going to do whatever is in here. So if I just change this to false, then it's going to print whatever the condition was false. And then we can have this series. This is something that we showed in the program earlier, but if, and then elif combines else and if. So if this is not true, then it'll move on to this line. And else, if this is true, then it'll do this. Else, if this is true, and it'll just keep going on, and then it will always do this is, if none of the other ones were true, it's going to do this. So since it was testing this, it's not even going to evaluate anything later. But if we move this to false and we change this to bow, then it's actually going to skip all the way down, all the way to this else here. And if we do Flavio, we can print that, and then it's going to say hello Flavio from right here. Okay, that's all we're going to talk about for this for now, since we've already covered it earlier in the course. Now I'm going to go into more detail about lists. Lists are an essential Python data structure. And so an example of a list would be, let's create a list called dogs. So we're going to create the dog names. We have Roger, we have Sid, and this allows you to group together multiple values and reference them all with a common name. So we have a list of dogs, and this is just 2 strings. So the list is always going to have the opening and closing brackets, and each item in the list is going to be separated with a comma. And a list can hold different types of values. So these are all strings, but we can have a string, an integer, a string, a boolean, and you can mix different types of data types in a single list. And then you can check if an item is contained in a list with the in operator. So we talked about the in operator earlier, but let me show you how that works. So we're going to print, here's where we can use the in operator. We're going to check if Roger is in dogs. So let's see. So run that, true. But now let's check if Bo is in dogs. Well, false, because it's checking. So this is how you can check if an item is in a list. You can also define a list as an empty string. So I could actually just remove all this, and now we just have an empty list. And this is obviously still going to be false because there's nothing in that list. But let's go back to when we had some items in the list. And you can reference items in a list by their indexes, starting with 0. So I'm going to do dogs, and then I can use these brackets. So, and now I'm going to put so this is where we're going to reference the thing, an item from the list, and I'm going to type in 0, which will be this item right here, Roger. Or I could put 2, and it's going to do 0, 1, 2, and now we're going to have Sid. And the same. And you can use this same notation to update an item in a list. So I'm going to add another line of code here and put dogs2 is going to equal Bo. And now I'm just going to print the entire list here. And now, instead of being Roger1 Sid true, it's Roger1 Bo true, because we've updated the item at index 2 to be Bo instead of Sid. Now you can also use the index method. So instead of, like, if I want to find the first item on the list, I could do it like this. So you can also use a negative number here, just how we saw in the string. So a -2 is going to start with 1, 2. Actually, let's do -1. So it should return true here. Okay, true. So it starts with this one if you put a negative number. You can also extract part of a list. Now, this is very similar to what we showed using with the string. Let me just add another item here. Now, I am going to use the colon to do part of a list. So I'm going to do 2, 4, and so this is a slice. So it's going to start at the second, or 0, 1, 2, which is now Bo, because we changed it to Bo, and it's going to go through 4. It's going to go through 4, but not including 4. So it's going to be 2, 3, and then not 4. So it's just Sid and true, or Bo and true, because we updated 2 to Bo. And you can also just leave this blank, so it's going to go through the end of the list, or if you leave the first number blank, it's going to start at the beginning of the list, and we can go through, for instance, index 3. And so that's a way to slice the list. You can also use the length function. So let's find out how many items are in the list. I'll use the length. The length of dogs is 6. There's 6 items in the list. We can also add items to the list by using the append method. So I'm going to do dogs.append, and then I can add an item. So I can say something like Judah, and now if we see the length, there's now going to be 7, and if we just print the full list, then we can see all the items, including the one that was just added. We can also use the extend method. The extend is another way to add an item to a list. So if I do, instead of dogs.append, I can do dogs.extend, and then I'm going to pass in, instead of just passing in the string, I'm going to pass in the item as a list. So and it's going to add it just the same, but now I can actually combine 2 lists together. So I'm going to put a 5. So if I do this, we can see now we are taking this list and extending it by adding this list on the end. This is a 2-item list, and we have that 6-item list, and now we have the 8-item list. You can also use the plus equals operator. So to use the plus equals operator, I'm going to do dogs. It's the same. It's going to do the same thing as extend. So plus equals, and then we have this list. Take this parentheses off here, and it should look exactly the same. See, it's showing up the same thing up here. So the plus equals is going to be the same thing as extend, where it takes the list that already exists and adds this other list to the end. And when you're using the extend or the plus equals, you don't want to forget the square brackets here. So if you forget the square brackets, and let's say I'm just going to add this item to the list, it's now actually going to put each letter individually here. So if you can kind of see it better if I move over here. So so you want to make sure you put the brackets. And another thing you can do is remove. You can remove an item using the remove method. So I'm going to do dogs.remove Sid. Okay, now I'm going to play it here, and it's saying What did I do wrong here? Oh, obviously, I'm removing Sid, but we've already changed the element of Sid to Bo. So let's remove Quincy. And let's try that. Okay, so now there's no Quincy. So another common thing to do, another common list method is pop. So if I do dogs.pop, it's going to remove and return a single item. So first I'm going to do print dogs.pop, and then I'm going to print dog. So first it's going to return 5. That was the last item that we added onto the list. And now when I print the list, that item's not on the list. So pop is going to remove the last item from the list, and it's going to return the last item. It's going to return and remove the last item from the list, and then it's not on the list anymore. Now let's make this, let's simplify this. Just go back to the initial list, and I'm going to change this to items. Now I'm going to show you how to add an item in the middle of a list at a specific index. You can use the insert method. So I'm going to do items.insert. I'm going to put the index, which is we're going to insert at the index number 2, and the item is going to be test. And then I'm just going to print that, print items, and then I'll run that, and then we can see at index number 2, we now see the item test. Now, to add multiple items at a specific index, you need to use slices. So let me show you how you would do that. So we're going to do a slice, and then I'm going to set that equal to test1, test2. We print that. So now you can see we have test1 and test2 right here, kind of right behind this search thing here. And we've inserted multiple items into the list, starting at index 1. Now you can also sort a list. So if I do, here we go, items.sort, it will sort the list. But you have to make sure, okay, we have an error. It's not supported between, we have a combination of ints and strings. So let's make it so it's all strings in the list. And then it should be able to sort it. Okay, now the strings are in alphabetical order. And if we were using integers or floats, then they would just be in numerical order. Now, one thing that's interesting about that, if I change this to Bo, you'll see now we have this at the beginning and this at the end. So the sort method orders uppercase letters first and then lowercase letters. So to fix that, actually to make it make more sense, we're going to change that to Bob. And to fix that, within the sort, I'm gonna put key equals str.lower. And now it's going to sort these correctly how you would imagine, not caring about uppercase or lowercase letters. Sorting modifies the original list content. So to avoid that, you can copy the list content using, let me show you. If we do items copy equals items, and then we make a slice with nothing at the beginning and nothing at the end. So it's going to start at the beginning of the list to the end of the list. And now we can have a copy, and I can print items copy. So if I print that, so now we see we have the sorted list that we ran the sort on, but we also still have the original list. So with all the words in the original order. And there is also a way to sort a list without returning a new list. There's also a way to sort a list without modifying the original list. So instead of copying a list, what I'm going to do is items dot, instead of doing items dot sort, we're going to use a global function called sorted. So in the sorted function, we are going to pass in two parameters. So first is the list, items, and then the second is how we're sorting it. So this just makes sure that the case of the letters don't matter. And then I'm just going to print that. Now if I run this, you can see we printed the sorted list, and now we're printing the list, and it's no longer sorted because this created a new list without modifying the original list. Okay, now let's learn about another data structure called tuples. So this time I'm going to put tuples. So we're using a comment here. So tuples are another fundamental Python data structure. They allow you to create immutable groups of objects. This means that once a tuple is created, it cannot be modified. So we already saw that we could modify lists, but a tuple, you can't even add or remove items. They're created in a way similar to lists, but using parentheses instead of square brackets. So for instance, I'm going to do names equals, instead of using square brackets, we're going to do parentheses, Roger and Sid. Okay, so a tuple is ordered like a list. So you can get its values by referencing an index. So I could say, for instance, names, and if I do the bracket, I could put a 0 here to return Roger. And then you can also use the index method. For instance, names dot index, and then I can pass in something like Roger, and then this is going to return 0 because it's going to get the index number of that. So as with strings and lists, using a negative index will start searching from the end. So I could do that. I can do -1 to start, not -0, -1 to start searching from the end here. And you can count the items in a tuple with the length function. So I could do, if I do length and then do names, if I printed that, it would just print 2 because there are 2 items in that tuple. Then you can also check if an item is contained in a tuple with the in operator, very similar to a list. So I can do, this time I will print it. I'll do print Roger in names. So if I print that and run it, we'll see true because Roger is in the names. And then you can extract part of a tuple using slices, just like we could do with strings and lists. So I could do names, and then I could do 0 starting at the 0, 2. So that's just going to start at the 0 index and be done at the index 2. And then you can use you can get a sorted version of the tuple using the sorted global function. So remember, when we were looking at lists, when we used the sorted function, it created a new list. So when we're using the sorted function for tuples, it creates a new tuple. So I can say sorted names, and this would put them in alphabetical order. They already are in alphabetical order, but say there was one more word in this list, and then I can print this to print the sorted version, but it's not actually going to modify the list because you cannot modify a tuple. And then you can create a new tuple from existing tuples using the plus operator. So I could say something like new tuple equals names, and then I can use the plus operator, and then I would just say Tina and Quincy. I could add a few. So these will combine 2 tuples into a new tuple, but you can never, like I said, you can't actually modify the original tuple. Now let's learn about dictionaries. Dictionaries are another very important Python data structure. While lists allow you to create collections of values, dictionaries allow you to create key value pairs. we already discussed dictionaries a little bit, but now we're going to discuss even more about dictionaries. So let me give you an example of a dictionary with just one key value pair. So dog equals, and then we're going to use the curly braces to create the dictionary, and I'll put name, and then I will put Roger. And just like any type of strings, we could make these single quotes or they could be double quotes. And the spaces here are not very important, but it's common to put spaces in between these things for better readability. And the key can be any immutable value. So this is the key and this is the value, and the key can be any immutable value, such as a string, a number, or a tuple. The value can be anything you want. So a dictionary can contain multiple key value pairs. So like for instance, we got the name, we can have age, and that's going to be 8. And you can access individual key values using a notation like this. So I can say dog, so I'm using the bracket notation. I can do name. So if I print this, it's just going to print Roger. And then again, I can use the single quotes too if I want. And it still prints Roger. And then you can use the same notation to change the value stored at a specific index. So let's say I want to change the name. So if I do dog, and I'm going to say that the name is now going to equal Sid. Now I'm just going to print the whole thing, and we can see the name is now Sid instead of Roger. So another way to get a specific element is to use the get method. So if I do a dog.get, and then I do name, so I'm going to try to get the name here, it's going to return Roger. So one good thing about this is that you can add a default value. Like, let's say I'm searching for color, and it's saying none. It's giving it none because there is no color. But what if I want a default value? So I'm going to put comma, and then I'll put brown. So now if it cannot find the color in the dictionary, it's going to return brown. But if it can find the color, like let's say color, and this is a green dog. Okay, it'll return green. So with the bracket notation that I was showing you earlier, you cannot have a default value. So that's one good thing about the get method. Now, you can also use the pop method to retrieve the value of a key and delete the item from the dictionary. Well, we also showed the pop method for lists. So, for instance, I can say get.pop, and then I will pass in name. And then right after that, I'm just going to print dog, the whole dictionary. So first we're going to get Roger, and then when I print the dictionary here, it's not going to show Roger anymore because we deleted it. Pop will return the item and delete the item. Now you can also use a method called pop item. The pop item method, well, let me show you that one. Pop item, it's going to retrieve and remove the last key value pair inserted into the dictionary. So in this case, it should be color. So if I run this, it's going to return color green. And now when I print out the dictionary, it's not going to show color green because that was already removed. It removed the last item. You can also check if a key is contained in a dictionary by using the in operator. So we're going to try to find out if color is in dog. If there's a key called color in dog, we run that, and it says true. Another thing we can do is get a list with the keys in a dictionary using the keys method. So if I do dog.keys, and then we'll run that, it's going to show the keys. So the keys are name, age, and color. we can see that it's inside this thing called dict keys, but we can also pass this into list, so we return an actual, just the list part. So now we can see it's just an actual list, name, age, and color. And then we can do the same thing with values. So instead of dog.keys, let's do print dog.values. We'll print that. And you can see we have Roger 8 green. We can pass it into a list to return just the list here, Roger 8 green. And then finally, if we just do items, it's going to return all the items in the list, or all the items in the dictionary, and convert it into a list. So you can see this is the first item in the list, this is the second item, and then we have the third item here. So we can see each item of the list, each item of the dictionary is now in a list. And then, like a lot of the other things, we can use the length function, and I'll just put dog, and we can see that there are 3 items in dog. Now you can also add a new key value pair to the dictionary. So let's say I want to do dog food, or it doesn't even have to be a single word. I could put favorite food, and I'm going to say meat. And now we're going to print that. Let's see, what did we, oh, this was supposed to, I did that a little wrong. There we go, this is actually how you do it. You use the bracket notation equals and then just put what it equals there. Okay, now you can see that we now have a new item on the list, favorite food, meat. Then you can also delete an item from a list, or delete a key value pair. So I'm going to, del means delete, dog, or dog, there we go. And this time I'm going to delete color. And I'm just going to use single quotes instead of double quotes to show you that it doesn't really matter the type of quote. And now you can see we don't know what color this dog is. It's no longer a green dog. And then you can also copy a dictionary. So if you want to make 2 copies of a dictionary, you can do it like this. Dog copy, that's the name of the new dictionary. I'll do dog.copy, and that would be the new copied version of the dictionary. Okay, now we are going to talk about a new thing called sets. Sets are another important Python data structure. Sets kind of work like tuples, but they're not ordered, and they are immutable, so you can change them. You can also say that they kind of work like dictionaries, but they don't have keys. They have an immutable version of a set called a frozen set. So let me show you how you would create a set. So let's do names, and we're going to use curly brackets just like that, and just like that. So we have 2 names. So you can see the difference is a dictionary, you use the curly brackets, but there's going to be key value pairs. But this doesn't have key value pairs. In a list, it's just going to be a item after item like this, but there's going to be brackets instead of curly braces. So one thing about the sets is that they are not ordered. So sets work well when you think about them as mathematical sets. So for instance, we're going to create a set 1 with Roger and Sid, and we're going to have a set 2, which is just going to have Roger. And so you can intersect 2 sets. So the intersection of these 2 sets will be set 1 and set 2. So if I just print that out, print intersect, and then we can just run that, and we can just see what. So it's just Roger. So the intersection of these 2 sets are just Roger, all the items that they have in common. You can also create a union of 2 sets. So instead of just calling this union, I'll put mod for modification, and so I can show a few different things with the same variable name. And the union symbol is just the straight line like this. It's not an I, it's just the straight line. It's on the same key as the forward slash, backslash, one of the slashes. Now we're going to get every single item in both sets, which happens to, in this case, just happens to be the same as set 1. But if we change this one to the word Luna, just a different name, and now we're going to get each item in both sets, or Sid, Luna, Roger for the intersection. And then we can also get the difference between two sets. So let me change this back to Roger, and for the difference between two sets, I'll use the minus, and the difference is just going to be Sid. That's the only thing that's different between the two sets. You can also check if a set is a superset of another, and if a set is a subset of another. So how you would do that is, so we're just saying, like, is this greater than that, which means it has everything in the other set? True. Now if we put it the other direction, does this set have everything in this one? No, it doesn't. You can also count items in a set with the length function. That's pretty self-explanatory. I won't even show it to you. We've seen the length function so many times. You can also get a list from the items in a set by passing the set to the list constructor. So I'm just going to remove this, and we will do list set 1. Okay, so now we have a list of the set. And then you can check if an item is contained in a set with the in operator, just like the list and the other places we use the in operator. And then one more final thing about a set. A set cannot have two of the same item. So that's another thing that's useful about sets. So if I type in Roger, so now we have Roger, Sid, Roger. If I play this, we'll see it's only going to print Sid, Roger. It's not going to add the Roger twice to the set. So that's another useful thing about sets, is it makes sure there's only one of each item in the set. So if you have a list that has multiple items, you can convert it to a set, and then it'll just make sure there's only one of each thing in that set. Now let's talk more about functions. We already talked about functions in the last section, but we're going to do a review and then go into even more detail about functions. So a function lets us create a set of instructions that we can run when needed. And I'm just going to paste in a function. And again, the indentation, it can be either 4 spaces, 2 spaces, as long as it's indented the exact same amount. So functions are essential in Python and in many other programming languages. They help us create meaningful programs because they allow us to decompose a program into manageable parts, and they promote readability and code reuse. So this one is a function called hello that just prints hello. This is the function definition. So there's a name called hello, this is the name here, and then the body of the function, which is the set of instructions. And the body of the function is everything that's after the colon and everything that's indented one level on the right. So to run this function, we must call it. So I can just type in hello, hello. And then this is the syntax to call the function, and I can call it multiple times. So I can just copy this and paste it. And now if I just run this program, it's going to print hello 3 times. The name of the function is very important. So the name of the function is hello. It should be function name should be descriptive, so anyone calling it can imagine what the function does. A function can accept one or more parameters. This is something else that we saw before, but I can type in a parameter right here, and this becomes a variable that we can use in the function. So I can change this, and instead of printing hello, it's going to print hello, and then we'll just put name. And now I can call the function with the name, and I can actually call it with different names. So we'll do Bo, and we'll do Quincy, and then if I just play that, we see hello Bo, hello Quincy. So as you can see, we call the function by passing the argument. And again, you can use single quotes or double quotes here. It's better to be consistent, just
always use single quotes or always use double quotes. But for teaching, I like to switch it up to emphasize that you can use either. So let me tell you about the difference between parameters and arguments. These two words, parameters and arguments, are sometimes used interchangeably, and it's common to get confused about the distinction. We call parameters the values accepted by the function inside the function definition, and arguments are the values we pass to the function when we call it. Also, an argument can have a default value that's applied if the argument is not specified. So let me show you how I would do that. So we have it named, so right now it always needs to get a name. Well, first let me show you what would happen if I called the function without passing the name. I'm just going to run that, and we can see we're going to get an error. Hello, missing one required positional argument, name. But we can make it so you can call this function without passing in a name, where it's optional. You can if you want. So I'm going to put an equal sign, and then I'm going to type in my friend. And just to make this consistent, I'm going to make this all double quotes. Okay, so this is now an optional argument. So it's you can pass in the name, but if you don't pass in the name, it's going to default to my friend. So I'll just run this again with that default value, and now it's hello Bo, hello Quincy, hello my friend, because we called this and we didn't specify any argument or parameter. And then we can also accept multiple parameters. So I'm just going to get rid of this default value, and I'll put age. So now we're accepting a name and an age. So we can now use both parameters in our function. So I can do plus hello name. You are, and we're going to add the age. And now it's going to be passed in as a number, but we're going to convert it to a string. So you are years old. And then we have to make sure to add a space in here. So there'll be a space after this word, then the number, then a space, and then years old. So I'm going to now have to pass in the number. And now I can run this function. Now, showing the red squiggly lines, sometimes the red squiggly lines will appear when it's actually correct. So am I doing something wrong here? Oh, I need to put the parentheses. If the red squiggly lines appears when it's actually correct, they'll go away usually within a few seconds or if you hit enter. So that actually was a problem. I forgot the parentheses at the end. So you can see this is what the whole function looks like if it's all on one line, but I'm just going to move that over. So hello Bo, you are 39 years old. So we've used the name and the age. So parameters are passed by reference. All types in Python are objects, but some of them are immutable, including integers, booleans, floats, strings, and tuples. This means that if you pass them as parameters and you modify their value inside the function, the new value is not reflected outside of the function. Let me just give you an example of that. So if I'm just going to paste in some new code here, and we can see we have this function called change, and we're going to pass in this value. If we pass in this val variable 1 to the change function, and we set value to 2, well, then we're going to print the value and see what happens. And you can see it's now just 1 here. So it didn't change the value. So what we change inside the function doesn't affect anything from outside the function. And then you can see we have these orange squiggly lines here. Local variable value is assigned but never used. It's just showing that actually this isn't really doing anything. Once it's inside the function and when we change it, it doesn't change anything outside the function. So if you pass an object that's not immutable, you do change one of its properties, and the change will be reflected outside. So this was mutable. This is immutable. An object that would be mutable would be like a dictionary. So if I change this to a dictionary and I put name and I set it to Bo, but then inside the change, I do value.name, or not, I'll put the brackets, value name, so the key of this dictionary, and I set that to Sid, and I run this, we'll see now the name has changed to Sid. So we used the change function to change name to Sid, and now it actually is changed because a dictionary is mutable. So a function can also return a value using the return statement. So I'm going to update this whole thing and talk about return statements. A function can return a value using the return statement. So it's going to return this name that we then can continue to use in our program. And it doesn't have to return name. It can return anything that happens inside the function. And when the function meets the return statement, the function ends. So you can have a return statement and have code after it, but it will just end. Like, for instance, if you have the return statement in a conditional, like in an if statement. We can also omit the return value. So it's just going to end the function and not return anything. So I had mentioned having the return statement in a conditional. So that's a common way to end a function if the starting condition is not met. Like, for instance, if we update the function to this, so if not name, return this. So if not name, return, or else, you don't even need an else because this will just end the function and you don't even need an else. This will happen if there is a name. Now, we just said that you have to pass in something if you don't have a default value. So the way to get to that would just be to call the function with false. So if we call with false, then it's just going to return. It doesn't do anything. But if we call it with Bo, then let's see. Hello, Bo. So you can also return multiple values by using comma-separated values. So for instance, I'm just going to take this part off here and then add a return statement. Return, and then I can return the name. I can return Bo, in case that's not the name. I can return 8, and then I can call this, and I'm just going to call this with Sid, and we can see what happens. Now, it doesn't actually print what's been returned, but if I print this, here we go, then we can really see what happens. So in this function, it's going to print this, but now we're also going to print what's returned. So let's see what that looks like. So this is when we print what was returned, it looks like this. So it's Sid, Bo, 8. So one thing related to functions and also related to other parts of Python is variable scope. So let's look at this. We've declared a variable up here, and when you declare a variable, that variable is visible in parts of your program depending on where you declare it. So if you declare a variable outside of a function, the variable is visible to any code running after the declaration, including functions. So we call this a global variable. So we've declared this before the function, so we can now access it inside a function and also outside the function. So if so we can see 8 and 8, and it shows right here what's going to show in the console here. But if we declare a variable inside a function, let me give you an example. If we declare this variable inside the function, I'm just going to move it down to here. Now it's a local variable, and it's only visible inside the function. So let me just delete this because it's not actually going to be doing that. So if I run this, we're going to see there's an error. Name age is not defined. We're trying to print the age here, but since the age was declared inside the function, it's not available outside the function. It's only available inside the function. So you just have to be aware. Sometimes there's local variables that only apply inside the function, and there's global variables that can apply inside a function and outside a function. Okay, now let's look at something else with functions, and this is nested functions. Functions in Python can be nested inside other functions. A function defined inside a function is visible only inside that function. This is useful to create utilities that are useful to a function but not useful outside of it. So you might ask, why should I be hiding this function if it does no harm? Well, one, because it's always best to hide functionality that's local to a function if it's not useful elsewhere. Also, because we can make use of closures, which we'll talk more about later. So look at this example. So we have this function talk, and inside the function we defined another function called say. And then what we do is that we can call that say function inside the function. And so the way this works is we pass in the phrase. So here's the phrase, and the phrase is, I'm going to buy the milk. And here we split it. So split is a way to create a list out of this string. So we have this string, but it's going to split it on every space. So it's going to create a list of each word individually, and then we're going to run this loop. More on loops later, and we're going to, for every word in the words list, we're going to say the word. We're going to say the word. It's just going to print the word. So if I just run that, I am going to buy the milk. And every time it prints it on a new line. So this would just be an example, because we're never going to want to use this say function outside of the talk function. So it's better just to put it inside the talk function. And then I'll just paste in another example here. If you want to access a variable defined in the outer function from the inner function, you first need to declare it as non-local. So we're using non-local here at non-local count, and this allows us to access this variable that was declared inside the out. So this is the outer function count, and we have this variable called count, and to be able to access that variable in the inner function, we have to call it non-local, or we already talked about variable scope, and if we didn't call this non-local, then we could not access the count variable from inside the function. So like for instance, I'm going to run this, it's going to print the count, which is just count plus 1. It's just adding 1 to this number. That's all the function does. But if I take off this word non-local here and I run this, we're going to get an error because it doesn't know what count is. It doesn't know that we're referring to this count in the inner function. So we'll just put that back on there, and then it should work again. This is especially useful with closures, which we're just about to talk about. So closure is a special way of doing a function in Python. If you return a nested function from a function, that nested function has access to the variables defined in that function, even if that function is not active anymore. So let me show you an example. I'm going to paste in code that'll be very similar to this code, but just a little different, and then I'll explain it. So now instead of count, it's a counter. So we're returning count from this nested function, and from the outer function, we're returning the nested function. We're returning the increment function. And then here, instead of just calling the function directly, the outer function, we're assigning it to this variable. And now we're going to print, we're going to call this variable, which is the returned inner function. So we're basically calling the inner function, and it's still going to, because we're calling the inner function, it's not going to reset the count to 0 every time, and it can keep track of that value. And we have this using a comment what it's going to return, but we can also run the program, and we can see 1, 2, 3, just like that. So we return the increment inner function, and that still has access to the state of the count variable, even though the counter function has ended. So let's move on to objects. Everything in Python is an object. Even values of basic primitive types, like integers, strings, floats, are objects. Lists are objects, as well as tuples, dictionaries, and pretty much everything. So objects have attributes and methods that can be accessed using the dot syntax. For example, let's define a new variable of type int. So I'm going to do age equals 8. Age now has access to the properties and methods defined for all int objects. This includes, for example, access to the real and imaginary part of that number. So I can do print age.real, and then if I just run that, the real part is 8. I can also print the imaginary part of the number, imag, and there is no imaginary part of the number, so it just does 0. I can also get the bit length, age.bit length, and if I run that, we can see the bit length is 4. So the bit length method returns the number of bits necessary to represent this number in binary notation. So there's just a lot of things that you can use for all int objects, and these are just a few of them. So a variable holding a list value has access to a different set of methods. So I'm going to update this again. We're going to do items equals, and we're going to create a list 1, 2. So I can do items dot append. I can append a 3. I can append another item. I can do items dot pop, which is going to remove and return the last item, which is the 3. And the methods, so these are the methods, append and pop, and the methods available to an object depend on the type of value. The ID global function provided by Python lets you inspect the location in memory for a particular object. So for instance, I could do print, and I'm going to do ID. What's the ID of the items object? And we can see this is the location in memory. So some objects are mutable while others are immutable. This is something that we already talked about a little bit. That depends on the object itself. If the object provides methods to change its content, then it's mutable. Otherwise, it's immutable. Most types defined by Python are immutable. For example, an int is immutable. There are no methods to change its value. So if you increment the value, like with age equals age plus 1, it's actually going to create an entirely new value. So it's not going to even be the same object at all, because age, it has to create a whole new one to reassign it. But something like a dictionary, it would actually be the same object, but you could just change different parts of it. Now let's talk more about loops. So this is something we already discussed a little bit in the previous section, but loops are one essential part of programming. And in Python, we have 2 kinds of loops: while loops and for loops. So before I show, I'm going to paste in this code, but I just want to show something really quick. See how there's a line, like dotted line here and a dotted line here? This is showing the default indentation, which we can change. So I'm actually going to go and change that really quick. Wait, I think I'm going to have to, yeah, I'm going to zoom out so I can get to this, and I'm going to change the indent to 4, and now it's not going to have a little line right in there. So now I'm going to go back up here, and let's zoom in again. Okay, so let's talk about while loops. While loops are defined using the while keyword, and they repeat their block until the condition is evaluated as false. So while condition equals true, so this particular example is an infinite loop. It never ends, because this condition is always going to, so if we run this program, which I'm not going to do right now because it just goes on forever, while this condition is true, keep running the code inside the loop, all the lines of code that are indented the same amount. So let's halt the loop right after the first iteration. I can do condition equals false. So now, if I run it, it just runs the loop one time. So in this case, the first iteration is run as the condition is evaluated to true, and then at the second iteration, the condition test evaluates to false, so the control goes to the next instruction after the loop, which in this case, there is no next instruction after the loop. It's common to have a counter to stop the iteration after some number of cycles. So here's a while loop with a counter. So you start the counter at 0, and then while count is less than 10, we're going to print this. Count equals count plus 1, so it's going to increment the counter every time until we get to the end. So it's going to print this until eventually the count is greater than 10. So, or 10 or greater, while count is less than 10. So once it gets to 10, the loop will stop. Again, another way to do this, we could have just done plus equals 1. So if I run that, it's going to do the exact same thing. And the other type is the for loop. So using for loops, we can tell Python to execute a block for a predetermined amount of times up front and without the need of a separate variable and conditional to check its value. It's commonly used to iterate the items in a list. So we have this list. There's obviously 4 items here, and then 4 item in items. So items is this list, and then for each item in the list, we're going to print the item. Pretty straightforward, and it prints each item in the list. Or you can iterate a specific amount of times using the range function. So let's say we're not going to define this here. We're just going to do for item in, and then here I'm going to type in range, and then I'm just going to type in a number. How about 15? So I'm using the range function that basically just returns a list. And then if I do that, we can see it's going from 0 to 14. So the range function is going to return a list that goes from 0 to 14. So there's 15 items, and it's going to print the items. Now, if we just go back a few steps to when we had the list here, I can show you how to get the index. So right now, it's just printing the items, 1, 2, 3, 4. But what if we want the index of the list? We can do that by wrapping the sequence in the enumerate function. So for items in, and then I'm going to do enumerate. I'm going to pass in. So this is going to return each item and the index of the item. And since there's going to be an item and an index, but it's actually the index and then the item, I'm going to type in index comma item. So this enumerate is going to get the index and the item. So now I can print the index and the item here. And if I run that, so index 0, item 1, index 1, item 2, index 2, item 3, and so on. And it doesn't even have to be numbers. We can do names. And if I just run that, whoops, not that one. And then we can see the index and the item. Then let me put in some more code here so I can talk about break and continue. Both while and for loops can be interrupted inside the block using either break or continue. Continue stops the current iteration and tells Python to execute the next one. And break stops the loop altogether and goes on with the next instruction after the loop ends. So I'm going to just play this. So here we're saying if item equals 2 continue, so that means it's going to skip that iteration. So if I play this, 1, 3, 4. So it's not going to get to the print item because it's actually skipped that iteration. It just doesn't run any code after the continue if this is true. And so it doesn't print 2. So if we change this to break, it'll be a little different here. This time it's going to just print 1 because now it's breaking out of the loop entirely and it's not going to run any more iteration of the loop. Okay, let's talk about another thing, classes. Classes in Python. So in addition to using the Python provided types, we can declare our own classes. And from the classes, we can instantiate objects. An object is an instance of a class. A class is the type of an object. So here's an example. I'm going to create a class called dog. So to create a class, you just put the word class and then put the class name. And now I can add a method for the class. So to define a method, I'll just do define bark, and I'm going to put the word self here, and inside this I'll print woof. Okay, so self as an argument of the method will point to the current object instance and must be specified when defining a method. So when you're creating a method inside a class, you're always going to start with self. So we create an instance of a class, which is an object, like this. So I'm just going to put Roger equals dog. Okay, so I've created a dog just like this. And then I can print type Roger. So let's see what the type of this Roger is. We can see it's a class, it's a dog class. Roger is a dog. A special type of method there's a special type of method called init, which is a constructor. So let me show you how to create a constructor. We'll do def So we can use this a constructor like this to initialize one more properties when we create a new object from that class. So you can see we always have to add self, but now these are the two variables we can pass in when we create a dog, and that will be associated with that object. So down here, I can call dog, but I can pass in Roger for the name and the age. And now when we create this dog, it's going to assign the name to self.name, and it's going to assign the age to self.age. And let me show you how we can access that information. So I'm going to print, instead of printing the type, I'm going to do Roger.name. And now it's going to, when I do Roger.name, that's self.name. So self is Roger, and we do self.name, it's going to be the name that was passed in. And then we can also do the age, and then we can finally call the bark method. So we have bark here, and then we can see what that does. So I'm just going to run that, and we have Roger, we have 8, and then this is because I should have put parentheses here. So let me put parentheses after bark. And so we have wolf here. So Roger 8 wolf. And the reason why it says none here is because I didn't have to put the print. See, I put print because I was in this groove here of putting print on everything. But calling bark already prints wolf. So when I do it, when it's printing because since Roger.bark doesn't return anything, there's no return statement, that's why it printed none. So there'd be two ways to fix that. Either instead of printing wolf, I could return wolf, or I could just not do the print here. So let me just take that off. Okay, Roger 8 wolf. So one important feature of class is inheritance. Let me show you an example of inheritance. I'm going to create a new class before the dog class, and this is going to be a class called animal. And the animal class, I'm going to put a function called walk. And I'm going to you always pass in self, and this is going to print walking. And then we can make the dog class inherit from the animal class. So we have class dog, but if I put parentheses here, then I can type in animal, and now the dog class is going to inherit from the animal class. And now I can go down here, and after Roger.bark, I can do Roger.walk. And if I run that, okay, so Roger 8 wolf, but now it's going to be able to do walking. And you can see the dog class doesn't actually have a walk method, but it's getting it from the animal class. It's inheriting this method. And in that way, you are able to, I could create a class cat, a class frog, a class bird, and each of them could inherit the walk method, and then it would have walking. And we'll be doing a little more with classes in the final project in this course, because we'll be going a little more over object-oriented programming. But right now, let's talk about something new. I'm going to just delete all this, and we're going to be talking about modules. So every Python file is a module. You can import a module from other files, and that's the base of any program of moderate complexity, as it promotes a sensible organization and code reuse. So it's basically how you can create a software that has multiple Python programs in the same piece of software. So in the typical Python program, one file acts as the entry point, and the other files are modules and expose functions that we can call from other files. So let me just show you an example. I am going to open up this Files tab, and I'm going to create a new file. And this is going to be called dog.py. And now I have dog.py open. I no longer have the main.py open. And I'm going to define bark. And what bark is going to do is just print woof. Okay, now I'm going to, it's just going to automatically save for me. I'm going to go back to the Python file, and now I'm going to import dog. And let's see. Oh, it's just saying it's unused. I thought maybe I did something wrong, but that just means I imported dog and I haven't used it, which I'm about to do right now. So dog.bark. So now if I run this program, it's going to say wolf. But that's not from this file. It's actually importing this function from the dog file. So that's a way you can break up your code into multiple files. We can also use the from import syntax and call the function directly. Let me show you what I mean. So instead of import dog, I'm going to say from dog import bark. And then instead of calling it dog.bark, I can just call bark, because we're only importing bark. Well, we've imported bark directly instead of the whole dog. So I can run that, and it says wolf. So the first strategy allows us to load everything defined in a file. When I just said import dog, that allows everything defined in a file. So I could have a bunch of functions like bark or walk, name, or there could be a bunch of functions. If I just say import dog, it imports all of them. But the second strategy, from dog import bark, allows us to just pick the things we need. So we're only going to import the specific functions that we need. Those modules are specific to your program, and importing depends on the location of the file in the file system. So suppose you put dog.py in a subfolder. For instance, let's say I create a folder and I call it lib for library. And let's say I put dog.py in this subfolder like this. Now, in this folder, to make this work, I'm going to have to create an empty file named init.py. So I'm going to add file, and I'll do init underscore init dot py. And this tells Python that the folder contains modules. Now I'm going to go back to my main file, and I can import dog from lib. So I'm going to say from lib, that's that subfolder, import dog. And then I can do dog.bark. So let's run that to make sure there's no errors. It worked correctly. So I was able to import this file from the subfolder. Or you can reference the dog module specific function by importing from lib.dog. So I can do from lib.dog import bark. And now instead of calling dog.bark, I can just call bark. And it says wolf. So I'm going to close this here. And now let's talk about the Python standard library. So basically there's all these pre-built modules. You can load a lot of code from the standard library. Python exposes a lot of built-in functionality through its standard library. The standard library is a huge collection of all sorts of utilities, ranging from math utilities to debugging to creating graphical user interfaces. So there's a bunch of them, but here's some of the more common ones. We have math for math utilities, re for regular expressions, JSON to work with JSON, datetime, SQLite 3, OS for operating system utilities, random for random number generation, so statistics, requests for HTTP requests, HTTP to create servers, URLlib to manage URLs. So you can import these modules that allow you to get extra functionality. So we already looked at a little bit at the math one. We already looked a little bit at random in the first project that we did. But let's just kind of look at a little more how you would do this. So now we are going to use the math one. We're going to import math. And so this is how you would use a module of the standard library. So we already saw how to import modules that we created. It's very similar with the standard library. So now that I've imported math, I can now use functions and methods from the math module. So I can do math.square root, and I can pass in 4, and then I can just print that so we can see what the result is. Okay, 2.0. Or we can just like we saw before, instead of importing math, I can say from math import square root. And then instead of just doing math.square root, I can just call this square root method here, and it's going to do the same thing. So that's basically how it works for all the modules in the standard library. Okay, now we're going to start going over a few kind of miscellaneous, slightly more advanced topics in Python. So we're going to talk about how to accept arguments from the command line in Python. Well, first of all, let's see how to run a program from the command line in Replit. So let's say we have a program. It just says print hello. Okay, so we've been running it by just clicking this play button. But there's another way to run a program in Replit. I'm going to go over to the shell. So this is the command line in Replit. We can clear this. And now I'm just going to type in python main.py. Okay, so we call Python to run the Python program. And then we just put the name of our file, which is main.py. So whether you're in Replit or if you're running things locally, you should be able to run a program in the same way. Depending on how you install the program locally, instead of typing Python, you may type in Python 3. Sometimes the way people install Python, it'll be Python 3 because we're using version 3 of Python. So now let's see how you can call a program on the command line and pass in some arguments right when we run the program from the command line. So a basic way to handle arguments is to use the sys module from the standard library. So let me give you an example. So first of all, we're going to import sys. Now, just so you know, usually you're always going to have import statements on the first line. I'm just putting this comment on the first line to remind us what we're working on right now. So now we're going to import the sys library. Now I'm going to print, and we're going to print the argument, sys.argv. So this is how we can print all the arguments that were passed in when we called the program. So I'm going to see we have python main.py, and now I'm going to put bow 39. Okay, so you can see it's printing the list of arguments. So this is basically just a list. The first item is the name of the file. Then we have the first word and then the second one. And you can see they're both strings. Even though this is a number, it's coming in as a string. So then we could do something like this. We could say name equals sys.argv, and then I would get the element at index 1, which is the name here, and I could print hello, and then we're going to do a name. Oh, hello, and then name. So let's call this again, and instead of, I'm not going to do 39, it's just going to be Python main.py Bo. Hello, Bo. So we've now been able to use the argument that was passed in. Now this is a simple way to do it, but you really would have to do a lot of work using this method, because you really should validate the arguments, make sure their type is correct, and you need to print feedback to the user if they're not using the program correctly. So I got zoomed out a little bit, and I'm going to show you this other method. So Python provides another package in the standard library to help you called argparse. So first you would import argparse, and then let me show you how you would use it. So you call argparse.argumentParser, and then pass in the description of the program. So the description of the program is this program prints the name of my dogs. Then you proceed to add arguments you want to accept. So for this example program, we are going to accept the C option, or it can be //C or -- color, and we are going to be calling it color. And then later we do parser.parseArgs, and then we can access args.color to get the color that was passed in. And then you can specify whether it's required and what help is going to go along with that. So let me show you how you would do that. We're going to do Python main.py. I'm going to put -c, and then I'm just going to put red. Okay, so you can see if I go this out a little more, you can see this is the command I called. This is the command I run. I pass in red, and then it just printed red. That's what we have right here. And so let me show you what would happen if we don't specify the argument. So if I just run it without the red, so it's now giving me some information. Usage. Well, main.py, we need to put -c, and then we have to put a color. And then it says the following arguments are required, this -c or -sc. So it's showing us that we need to, if we've called the program wrong, and we're going to need to call it with a -c. You can also set this option. We can set an option to have a specific set of values using choices. So after required true, after this comma, I'm going to type in choices, and I'm going to set this to equal. See, I have this empty dictionary, but I'm just going to, well, not a dictionary, but because there's not going to be key value pairs, but I'm going to do red and yellow. So now it can only accept two options. So I can call it here with red, but if I call it with blue, it will say invalid choice, blue. I need to choose from red or yellow. So using this argparse makes it easier to deal with arguments, and also it makes it easier to communicate information back to the user about what we're trying to get. So there are more options with this, but those are the basics. Now let's talk about something completely different, Lambda functions. So let me just give you a quick example. Lambda num times 2. So lambda functions, also called anonymous functions, are tiny functions that have no name and only have one expression as their body. So they're defined using the lambda keyword. And so this is going to be the argument, and this is going to be the expression. The body must be a single expression, and it has to be an expression, not a statement. So this difference is important. An expression returns a value, a statement does not. So it has to return a value. So the value that's being returned is the number times 2, the number that was passed in. It's going to multiply it by 2 in this example. So this is basically the simplest example of a lambda function. It just doubles the value of a number. And lambda functions can accept more arguments. So for instance, I could do lambda a comma b, and then we can multiply a times b. Lambda functions cannot be invoked directly, but you can assign them to variables. So for instance, I can assign this to the variable called multiply. So multiply is going to, this function is going to be assigned to this variable here. So then the way that I would use that, I could print, now I'll print the result of calling multiply, and then I pass in 2 and 4. So if I just run that, okay, 2 times 4 is 8. We can see right in the console here. And then I'm going to just zoom in just a little bit. So the utility of lambda functions comes when combined with other Python functionality. For example, in combination with map, filter, and reduce. So speaking of map, filter, and reduce, that's what we're going to talk about now. Map, filter, reduce. So Python provides 3 useful global functions that we can use to work with collections. So this is map, filter, and reduce. So first let's talk about map. And since they're functions, they're going to have the parentheses at the end. So map is used to run a function upon each item in an iterable item, like a list, and create a new list with the same number of items, but the values of each item can be changed. So here's an example. We have this list, and then here's the function, and then we are going to map through each item in the list. And so here's the function we're going to run. We're going to run this function on each item in the list, and now we're going to get a new list. So I can do print result. Now if we print that, I'll just run that function, and we can see, okay, we get a map object. So then we can always just pass it into the list function, and then we can run the program again. 246. So 1 2 3 became 246. So yeah, whenever you want to run a function on each item in a list, you can use map. And when the function is a one-liner, it's common to use a lambda function. So remember, we just talked about lambda functions. So now let me show you how you would do this as a lambda function. So double is going, this is going to be a variable, and we're going to assign it to a lambda function. And I'm going to, so now this lambda function takes the number a, and then does a times 2. So, and this we just keep the same because now we're using a lambda function here, and we're taking each number and passing it through this function where we have this is each number in the list, and we multiply it. So if I run this program, it should look exactly the same. And we can even simplify it even more. So this is where lambda functions really shine. Instead of assigning it to double first, I can copy the whole function. I can delete this completely, and now I can just put it right in here. So now we're mapping over this function, and we don't even have to create the function in a different line and assign it to a variable first. We can put the lambda function right in the same line right within the map. And now I run this, and it's going to give us the same result. So remember, we started with, when I first showed you this example, we had a much longer piece of code. Now we've simplified it with the lambda function. So the original list is left untouched, and a new list with the updated values is returned by map. The result is a map object, which is an iterable. So that's why we needed to cast it to list to print its content. Okay, now let's talk about filter. Let me just update the code here. It's kind of similar, but now we're using filter. Filter takes an iterable and returns a filter object, which is another iterable, but without some of the original items. So you can do so by returning true or false from the filtering function. So here's the filtering function. We are going to check if the item passed in is even. So so here's the list here. So you can see we're calling filter. We pass in the function, the filtering function, and then the list, and we're going to return true or false from this function. So if it's divisible by, if when you divide it by 2, we have 0 remainder, then it's even. So that would return true. So this line would return true. And then if not, it would return false if it's odd. So now any even number is going to be added to the result, and any odd number is not going to be added to the result. So basically we're filtering the list based on this function. And then here we just print, we convert that result to a list, and if we run that, it's 2. And obviously if we can just put in more numbers here and run that again, we have 2, 4, 6. And then we can, just like before, we can use a lambda function. So I'm just going to copy this here. We can just delete this whole thing, and we are going to put a lambda function here. So lambda. So now you can see we're just putting the lambda function in line here, and we are checking to see if this is going to turn true or false, whether it's even or not. And so I run the program, and it's going to give me the exact same result here. Okay, the final thing we're going to talk about is reduce. Reduce is used to calculate a value out of a sequence, like a list. So, for example, suppose we have this list of expenses stored as tuples. And so we have dinner 80, car repair 180, or 120. And we want to calculate the sum of this property in each tuple. In this case, the cost of the expense. So here's kind of the long way of doing it without using reduce. We basically take every expense in expenses, and then we add to the sum here, and we add expense 1. That's going to be the item at index 1, and then we get the sum, and we can print the sum. So that's kind of like the long way of doing it without reduce. But there's a quicker way. So to use reduce is a little different from map and filter, where it's not available. It's not available automatically. We have to import it from the standard library functools. So I'll do from functools or function tools import reduce, and now I'm going to create a new variable called sum, and we're going to set it to reduce. We're going to use reduce, and now I'm just going to pass in, I'm going to go directly to the lambda function. So lambda, let me just kind of explain this for a little bit. So reduce is the first is going to take a function, the reduction function, and then the iterable here. And the function has to take 2 arguments. So the first argument is the accumulated value, and then the right argument is the update value from the iterable. So we're going to continue adding these 2 items. We're going to basically add every item together and reduce the numbers at the first index all down to 1 value by adding them all together. So I'll just play here, and then we get the same number, 200. And you can see it's a lot quicker just to use the reduce function compared to the other code we had previously. Okay, next up we are going to talk about recursion in Python. Not recursion error, just recursion. And a function in Python can call itself. That's what recursion is. And it can be pretty useful in many scenarios. A common way to explain recursion is by using the factorial calculation. So let me show you how you would calculate factorial. This isn't Python code, this is just an example here. So when you do 3 factorial, that means you do 3, you multiply every number between this number and 1 together. So 3 times 2 times 1 equals 6. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 through 1 and so on. And then every number you multiply every whole number down to 1. So using recursion, we can write a function that calculates the factorial of any number. So let me show you. So here's the function. You can see inside the function, it's calling the same function. So a recursive function, it's always going to have a base case, that's this, and the recursive case. So the base case is when we're going to leave the recursive function. So if n is equal to 1, we're going to return 1, and that's basically going to get out of the recursive function. But if n is not going to equal 1, then we have the recursive case where we're going to call the function. So you always need to have need to have a base case, so eventually the recursion can stop. If the recursion doesn't ever stop, then you're going to get a recursion error. Basically, Python by default will halt recursions at 1,000 calls. That's when you get the recursion error. So this is going to get the factorial 3, but let's just do this a few more times so you can see the difference. So 3, 4, 5, and now we'll test this out. 6, 24, 120. Okay, now let's talk about decorators. So decorators in Python are a way to change, enhance, or alter in any way how a function works. Decorators are defined with the @ symbol followed by the decorator name just before the function definition. So, for instance, let's say we have a function hello, and it's just going to be the simplest function. We're just going to print hello. So to add a decorator, I'm going to put like this, an @ sign, and then the decorator name. In this case, we're going to type in log time. So the function has the log time decorator assigned. So whenever we call the hello function, the decorator is going to be called. A decorator is a function that takes a function as a parameter, wraps the function in an inner function that performs the job it has to do, and returns that inner function. So for instance, I'm going to create another function here that's going to be the log time function. And now we can do something before and after the function. Like, for instance, we can say print before, and then after, we are going to print after. Now if I run this, oh, and we have to call the function. That's always important. Now if I run this, before, hello, after. So you're going to often use decorator functions when you want to change the behavior of a function without modifying the function itself. So a few good examples are when you want to add logging, test performance, perform caching, verify permissions, and so on. You can also use one when you need to run the same code on multiple functions. Okay, now let's talk about docstrings. So docstrings. Documentation is hugely important, not just to communicate to other people what the goal of a function or class or method or module is, but it also communicates to yourself. When you come back to your code like many months from now, you might not remember all the knowledge you were holding in your head when you wrote the code. So at that point, reading your code and understanding what it's supposed to do, reading your code and understanding what it's supposed to do will be a lot more difficult. So that's one of the reasons why people add comments. So another way is to use a docstring. So let me show you what a docstring looks like. The utility of a docstrings is that they follow conventions. So they can be processed automatically. So this is how you would define a docstring for a function. Basically, you're putting the 3 quotation marks here, 3 quotation marks there, and then this is a description of what the function is. This is how you would define a docstring for a class and a method. So got the class, this is what the class does, this is what the method does. And then it's also common to place a docstring at the top of the file. So if you put a docstring at the top of the file, it's going to look like this, and it's going to explain what the file is all about. And docstrings can also span multiple lines, just like this is a multiple line docstring, as long as it has the 3 quotes at the top, 3 quotes at the bottom. And then Python will process the doc strings, and you can use the help global function to get the documentation for a class, a method, a function, or a module. For example, I'm going to go to the bottom of this, and I'm going to say print help, and then I'm just going to type in dog. Now I'll run this, and let me just run it again. So now you're going to get information about the dog. We know that the dog has a name and age, it's a class representing a dog, and it has these specific methods. And then it says more. We can get more information. Data descriptors defined here. We have, and this is just going to give us all this information about the dog. And so that's why it's good to use doc strings, because there are specific standards, and it makes it easier to get information using different helper methods. And standards allow us to have tools to extract doc strings and automatically generate documentation for your code. So besides just this help functions, there's a lot of other methods to pull out these doc strings and get information about your code. And next we will learn about annotations. Python is dynamically typed, so we do not have to specify the type of a variable or function parameter or a function return value. Annotations allow us to optionally do that. So if we want to actually show what type we're expecting for different values. So here's a function without annotations. And then here's how we would make it have annotations. So we want to make this function only accept an int. So I'm going to put :int, and then after here, I'm going to put, actually before the colon here, I'm going to put a little arrow here. And then I'm going to put in int. So now we're specifying that this function receives an int, and then it's also going to return an int. And you can do the same thing with variables. So if we have a variable, if I had a variable called count and it was equal to 0, I can add an annotation to make it be an int, like that. So now we're specifying that this variable is going to be an integer. Python will actually ignore these annotations. A separate tool called MyPy can be run standalone or integrated by IDEs to automatically check for type errors statically while you're coding. It will also help you catch type mismatch bugs before even running the code. A great help especially when your software becomes large and you need to refactor your code. Okay, now we'll talk about exceptions. It's important to have a way to handle errors, and Python gives us exception handling to do so. So for exception handling, you would wrap lines of code in a try block. And then inside this block, you'll put the lines of code. And then if an error occurs, Python will alert you, and you can determine which kind of error occurred using an except block. So we're trying some lines of code here, and then we're checking for a specific error, and then if that error happens, we would handle that error. But if a different error happens, then we will handle the different error. You can also catch all exceptions using an except without an error type. So at the very end, you could just do except, and then if you don't have an error type, then it's going to handle the rest of the exceptions. And just to make this clear, this is just an example where it says error 1. You have to put a specific error in that spot. You can also put an else block at the end to handle that will run if no exceptions are found. So if there are no errors in this code that's right up here, we can have an else and then run specific code at the bottom that runs if there's no errors. And then we can have a finally block. So anything in a finally block is going to just always run at the end. Whether or not there were exceptions or no exceptions, the code in the finally block is always going to run. The specific error that's going to occur depends on the operation you're performing. For example, if you're reading a file, you might get an EOF error, which just look like this, EOF error, which means end of file. If you divide a number by 0, you'll get a 0 division error. if you have a type conversion issue, you might get a type error. So let's try this code. So I'm going to just delete all this, and we'll do result equals 2 divided by 0, which you cannot do. So I'll just print the result. And then if I run that, we'll see this error over here. 0 division error, division by 0. So it's going to get an error when we run the code. And then whenever there's an error, anything after the error occurs will not happen. So we're not going to print the result because this line resulted in an error, so we're not going to run the following line of code. So now let's try adding that operation in a try block. So I'm just going to paste it all in here. And so we're putting the operation in a try block, and then we're expecting a 0 division error where we'll print cannot divide by 0. Finally, we will set the result to 1 and then print the result. So let me just run that code. See, cannot divide by 0, and then we print 1 because we set it in the finally block here. So this try block lets us recover gracefully and move on with the program. You can raise exceptions in your own code too using the raise statement. So I could type in raise, and then we can raise an exception intentionally. An error. So if I just run this, it will say an error because that's what we typed in. So you can make it say anything you want for your error. And this raises a general exception, and you can intercept it just like this. So I could say try, and then we raise that exception, and then we can do accept exception as error, and then we can print the error. Okay, if I run that, so now instead of we don't see all that red anymore because it's not stopping our program because of the error, but it's now printing the error message right here, just like that. You can also define your own exception class extending from exception. So I could do class dog not found exception, and then I will extend from exception, and then I can just put pass for this one. Here, let me adjust that. So pass here just means nothing, and we must use it when we define a class without methods or a function without code. So if you're not going to put anything, so this is just an example, so I can just put pass to mean that we're not going to have any code in this. So now we can try it out. So I'll just paste that. So we're going to raise dog not found exception, and then if we're going to handle this exception and just print dog not found. So let's try that. Yep. Dog not found, because it raised this exception here. We can also actually do something in the exception. So if I can say print inside, and then I'm going to run that, and they'll do inside and dog not found. The with statement is very helpful to simplify working with exception handling. For example, when working with files, each time we open a file, we must remember to close it. With makes the process more transparent. So let me show you some example code without the with statement. So we're not going to go into a lot of details about working with files here, but I just want to kind of just give this one quick example. So if we're going to be working with files in Python, so we can open the file, and then we can read the file, we can print the content from the file, and we're going to try that because there could be an exception. And then finally, we're always going to make sure to close the file. But an alternate way to do it would be like this. So with, we're going to open the file as file, and then content file.read, and then print the content. And with using with, it's going to make sure to automatically close the file at the end. In other words, we have built-in implicit exception handling, as close will be called automatically for us. And with can do a lot more stuff as well. This example is just meant to introduce its capabilities. Now let's talk about third-party packages. And we're going to talk about pip. So let's learn how to install third-party packages in Python using pip. The Python standard library contains a huge number of utilities that simplify our Python development needs, but nothing can satisfy everything. That's why individuals and companies create packages and make them available as open source software for the entire community. So the modules are all collected in a single place called the Python Package Index, which is available at pypy.org. That's pypy.org. And they can be installed on the system using pip. There's over 270,000 packages freely available. Most computers are already going to have pip installed, and Replit already has pip installed. So let me show you how you would install a package. We'd have to go over to the shell here. If you're not on Replit, you can just do it in your terminal. And I'm going to clear this here. And I'm just going to do pip install, and then you can put the name of a package. For instance, one popular package is called the requests package. It's an HTTP library. So I can do requests. And let me just, so you can see, I have to make sure I spelled that right. And it's going to install that package right now. So once we install this package, it's going to be available for all our Python scripts because packages are installed globally. And the exact location depends on the operating system. You can also upgrade a package to its latest version by doing pip install -u, and then I will just put the package name. So in this case, we'll just do request again. And then it's going to just update it to its latest version. In this case, it updated it from 2.28.0 to 2.28.1. You can also specify a specific version when you're installing, and then you can also uninstall a package. So I'll do pip uninstall requests. And then I can say that, yes, I do want to uninstall that. And then when you have a package installed, I'm just going to install request again. And then you always have to make sure you spell it right. So once you have it installed, you can do pip show requests. And then it's going to show some information about the package. So see, we can see the name, the version, the summary, and then a bunch of the author and a bunch of other information about the package. Okay, I'll just clear this. Now we're actually going to backtrack a little bit. We already talked about lists, but I'm going to talk about a more advanced way of using lists called list compression. List compressions. So list compressions are a way to create lists in a very concise way. So suppose you have this list like this. It's a list of numbers, and we'll just do 1, 2, 3, 4, 5. So we can create a new list using a list compression composed by the numbers list elements to the power of 2. Let me show you what I mean. So let's make a new list, numbers power 2 equals, and let me just show you how you do this list compression. So this is the list compression syntax. And if I print this, we can see that now we have every element in the list to the power of 2. List compressions are a syntax that's sometimes preferred over loops, as it's more readable when the operation can be written on a single line. So for instance, this is how you would do it with a loop. So what we do in a single line up here, we take a few lines to do in the method with a loop. So list compression just makes it simpler. And then you can do the same thing with map as well. But again, it's just a little more complex. Sometimes it's just simpler to use a list compression using this syntax here. Now let's talk about a few more advanced topics in regards to functions. Polymorphism. Polymorphism generalizes a functionality so it can work on different types. It's an important concept in object-oriented programming. So see, in here, we've defined the same method on different classes. So the dog has eat, and the cat also has an eat method. Then we can generate objects, and we can call the eat method regardless of the class the object belongs to, and we'll get different results. So we create the two objects, the dog and the cat here, and we're calling the eat method on both objects. And if we run this, you can see what we're getting: eating dog food, eating cat food. And so you could do a lot of things with this, like maybe you have a list of different animals, and then you can loop through that list and call the eat function or the eat method on each animal in that list, and they don't have to be the exact same class to be able to still run the eat method. So we build a generalized interface, and now we do not need to know that an animal is a cat or a dog. We just need to know that we can call eat on it. Now let's talk about operator overloading. Operator overloading is an advanced technique we can use to make classes comparable and to make them work with Python operators. So let's take this class dog. So here's a dog class, and you can create a dog with a name and an age. Then we'll create two dog objects. We'll do Roger equals dog, and we can pass the name and age. And then I'll make another one. We can use operator overloading to add a custom way to compare these two objects based on the age property. So, like, how could you compare this dog and this dog? Well, we can make it possible with operator overloading. So, let me just show you this example here. So, this function here, GT, is going to compare things to figure out what is greater than. Now we'll be able to compare two dog objects to see which one is greater than the other. And this is how we're going to figure out which is greater than. Return true if self.age is greater than other.age, which is the other one you're comparing it to, else false. Now we can do print Roger is greater than Sid. So we're trying to figure out if this is true or false. If I run this, it's going to say true. Roger is greater than Sid because 8 is bigger than 7. But if we put 9 here, run that, now it's going to be false. So in the same way we define this underscore GT underscore, which means greater than, we can also define methods for less than, lower or equal to, greater or equal to, or not equal. And then you can also create methods to go with different arithmetic operators. So we can do add, subtract, multiply, division, floor division, mod, power. So you can see all these different ones. You can make it respond to the different operators. So the example was just a greater than operator, but we can make functions to show how it's going to respond to all these different operators. There's even a few more methods to work with other operators, but you get the idea.
We've learned a lot about Python, and now we're going to bring a lot of what we've learned together to code a blackjack card game. And in the process, we'll learn about object-oriented programming in Python.
So we'll start by creating a new Python project on Replit. And I'm just going to close this tab here, and I'll zoom in just a bit. And just like our first project, I'm going to say what I'm about to do, and I want you to see if you can do it on your own before I show you how to do it. And with all you've learned so far, a lot of this you're probably going to be able to figure it out on your own as I give you the instructions without even seeing how I do it. But then you can come back to the video and see how I do it. Or I guess you can just watch and not even try to do it yourself. But you're going to learn a lot more if you try to code this by yourself along with me as I do it, but right before I do the different steps. So the first thing we're going to do is create a variable called suit and set it to equal to hearts, and then a variable called rank and set it to equal K for king, and then a variable called value and set it to equal 10. Okay, simple. 2 variables equal to strings and 1 variable equal to an int. So now we are going to add a print statement and print the phrase your card is with a colon at the end. And then we'll add another print statement and print the rank. So now we're just printing the variable here. And we're going to be doing a lot of refactoring as we create this program. Let's refactor this so it's just one print statement that's going to print your card is, colon, space, and then the rank. So we are going to be doing string concatenation just like that. So you can concatenate as many strings and variables as you want. So let's update the code so that the print function prints your card is K of hearts. So we just need to add of, and we have to make sure we put spaces on each side of the word of, and then suit. And let me just adjust this here. Okay, as you know, you can use a list in Python to store multiple values or items at a time. So above the suit variable, create a suits variable and assign it to a list of suits. In this case, spades, clubs, hearts, diamonds. We learned about how you can use the bracket operator to access a specific element in a list. The number inside the bracket specifies the index of the list to access. Remember, the indexes start at 0. So you update the suit variable so that the value of hearts comes from the suits list. Now we'll practice a for loop. So add a for loop to the end of the code that prints each suit. And then we'll just test this out. I really hope you actually are following along and trying it out right before I show it to you. That's how you're going to learn the best here. So spades, clubs, hearts, diamonds. Now this next thing is just to see if we can do it. So it's not going to be part of our final code. But right before the loop we just added, see if you can add another item to the suits list that's the string snakes. There's a few different ways to do it, but we will use append, snakes. So this is just going to append the word snakes at the end of the list. So if I run this, we can now see snakes at the bottom. Okay, now we're going to start the process of representing a full deck of cards with Python code. So we're going to actually get rid of a lot of this. We're going to get rid of all of this. We're just going to have the suits, and then we're going to have this for loop at the bottom. We're going to do a lot of refactoring as we go, mainly for educational purposes, but also so we can get a really good blackjack game. So we have a list of suits. After that, we're going to create a list of ranks. That's A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Now before the suits list, create a new variable called cards and assign an empty list to the variable. An empty list is just 2 brackets with nothing inside. Now in the cards list, there should be an item for each card in the deck. Each item in the suits list should be combined with each item in the ranks list for a total of 52 items or cards. Let's work our way up to that. So first, we'll update the print statement in the for loop so that it prints a list with 2 elements. The first element should be suit, and the second should be the first element of the ranks lists. So this should print an ace in every suit. So I'm going to update this so it's going to be a list with suit and ranks. The first item is going to be at index 0. Now I'll just print that out. So we got these 4 right here. Now instead of just printing an ace in every suit, let's print every rank in every suit. This can be done easily with a for loop nested within another for loop. So inside the for loop, add another for loop that loops through the ranks. Then update the print statement so that it's not just printing the first element in the ranks list, but it's printing the rank from the other for loop. So let me show you what I mean. We're going to do for rank and ranks, And then we have to make sure to indent this print statement so it's inside this other for loop. And this is now just going to be rank. So it's going to print the suit and rank, and I'll just run that. And now with this nested for loop, we have every card, every rank, and every suit. All 52 cards are printed as 2-item lists. An element in a list can be another list. So instead of printing 52 2-item lists, let's append those 52 cards to the cards list. So we already have the cards list here. It's empty, but I'm going to do cards.append. And so we're appending this item, all these items, to the cards list. So let's check what the cards list looks like by printing it out at the bottom. Remember, make sure this is not indented at all, and we'll do print cards. And I'll run that. And then here it is here. So this is the list. It's not one, there's just a comma between each item in the list here. You may notice that all the cards are in order in the cards list. For a game like this, though, the cards must be shuffled. So to help with this, import the random module at the top of your code. So that's we just do import random. Now we'll be able to use the random module. So this is going to import the random module, which contains a variety of things related to random number generation. And as you probably remember, when you import a Python module, it allows you to use additional commands in your code. Specifically, we're going to be using the random.shuffle function. So right before, at the end where it says print cards, we're going to call random.shuffle and pass in the cards list to that function. And then if I play this here, or run the program, we can see that these are not in order anymore. See, ace of spades, 3 of spades, king of diamonds, jack of hearts. So these are no longer in order because they've been shuffled. Now let's remove a single element from the cards list. This is similar to dealing a card from a deck, and this can be done with the pop method. So after the cards are shuffled, let's create another card variable and just pop off a card from the cards list and put it into that variable called card and just print that card. So I'll do card equals cards.pop. And then instead of printing all the cards, I'm just going to print a single card. I'll run the program. See, every time I run the program, you can see we're getting a different card. We're dealing a different card because it's been shuffled. So we've already learned all about functions, and now we're going to create a function. So create a function called shuffle that just has the single line that shuffles the cards. So it's just def shuffle, and then I just have to make sure this is indented. So now when we call the shuffle function, it will shuffle the cards. So right before the print statement, call the shuffle function, and instead of just printing the single card, print the cards. So do shuffle, and then I will print all the cards, and let's just try out the program. And we can see there was a problem. It's because we didn't put the colon here. So that's an important part of creating a function, is putting the colon there. Now we'll create another function called deal, and we'll put this line inside the deal function. So we're going to define deal, and I'll put the colon this time and make sure to indent that. And we can see this has a orange squiggly line underneath it because variables can only be accessed in the context that they were created. So the card variable will not be available outside of the deal function. You can get a value out of a function by returning a result using the return statement. So at the end, we're going to return the card. Okay, now we've taken care of that squiggly line there. So after the shuffle function is called, we'll call the deal function and assign the return value to a variable named card. Then we'll update the print function to print card instead of cards. So card equals deal, and then we'll just print the card. And again, we see a different card every time we run the program. What if you want the deal function to deal more than one card? Well, let's refactor the deal function to accept an argument. So any number of arguments can appear inside the parentheses when a function is created, separated by commas. Inside the function, the arguments are assigned to variables called parameters. So we'll start by making it so the deal function takes an argument named number. Then we'll make sure when we call the function we use the new parameter by making it so we're going to deal 2. So I'm just going to put number here. It's going to deal a number of cards, and we're going to deal 2. And I just didn't say this before, but now this is not one card anymore. So we're going to update this to be cards dealt. But there's a special shortcut. You can it's going to be Command or Control D. And now I'm actually selecting the card 2 different times. See, I now have multiple cursors here. So basically I selected the word, I double clicked to select the word, then did Command or Control D. Now it's selecting 2 words, and now I can type in cards dealt. So now I can type in 2 places at one time. So that's a cool thing that you can do in Replit, and you can do it in many other code editors. And I'll run the program, but it should still only deal 1 card, because even though we're passing this parameter into here, we're not doing anything with it yet here. So we want to update the deal function, so it's going to return a list of cards instead of a single card. In the first line of the function, create an empty list named cards dealt. Then update the last line of the function to return cards dealt instead of return card. So let's do that really quick. We're going to do cards dealt is going to equal an empty list, and I'll just copy that and paste it right here. Now, do you remember how to use the range function with a for loop? We talked about it earlier in the course. We just briefly touched on it. But let's create a for loop that's going to add a card from the deck for each card dealt. So we can do that by creating a for loop for x in range number. Now this is a common thing you're going to be doing in Python, creating a for loop that's going to be in range number, because now it's going to loop this many times. It's going to loop this many times, which is the number we passed in here. And we're going to do a few things in this for loop. First, we are going to actually do this what we already have, card equal cards.pop, and then we'll do cards dealt dot append card. So now we're just this card that we popped off the deck, we are appending it to the cards dealt, and then we're returning the cards dealt here. So down here in the code, let's separate out a single card from the 2 cards dealt. So let's create a variable called card and set it equal to the first item in the cards dealt list, and then we'll just print that card instead of cards dealt. So we are going to do card equals cards dealt, and then remember we just use the brackets and put 0 to get the first item in that list, and then we'll just print a card. Now I'm just going to test out the program, and we're still just seeing a single card here, but it's doing a lot more behind the scenes now. So now let's separate out the rank part of a single card. So after we create the card there, let's create a variable named rank and assign it the rank from the card. So we'll do rank equals card, and then I have to get index 1 because the rank, that's the 9 here, the second item in this card is the rank. So each rank has a different value. In Blackjack, the value of an ace, or an A in this program, is 11. Or sometimes it can actually be 1. It's going to be 11 or 1, but we'll get to the 1 part later. So Jack, J, Q, and K, which is Jack, Queen, and King, have the value of 10. And then the numbers have the value of the number. So we need to check what the rank is and set the value depending on the rank. So this is the perfect time for a conditional statement, specifically an if statement. Before the final print statement or program, we're going to add an if statement to check if the rank equals A. And if so, we'll assign 11 to a variable named value. So we'll do if rank, and I hope you remembered, if you're following along, I hope you remember to use 2 equal signs instead of 1 equal sign here. So if rank equals A, then value is going to equal, with a single equal sign, it's going to equal 11. Now if rank does not equal A, we'll want to check if it equals J, Q, or K. That can be done with an elif statement. For now, we'll just create an elif statement to check if the rank equals J, and then if so, we will set the value to 10. So we talked about the 3 logical operators, and, or, and not. You can use these 3 operators in conditional statements to check multiple conditions at once. So we want to check if rank is J, or rank is Q, or rank is K. So update the code with the ors. Now there can be any number of elif statements after an if statement, but at the end there can only be a single else statement, and like we discussed, the else is just going to be if none of the other ones are true. So let's add an else statement, and inside we'll just assign rank to value, because we've already gotten all the letters out of the way. The rest are numbers, and we can assign it directly to the value. Now we'll, instead of printing the card at the end, let's print the rank and the value. So I can just type in rank, comma, value, and when multiple values in a print statement are listed with a comma separating them, both values are printed with a space in between. So let's test this out a few times. Q10, 55, 66. So we can see every time we press it, it's going to be a random rank and value. Now we already talked about dictionaries in Python. It's like a list, but more general. You can think of a dictionary as a mapping between a set of indices, which are called keys, and values. So key-value pairs. Each key maps to a value. So above the print statement, let's create a variable called rank underscore dict for dictionary, and create a dictionary with 2 items. A key-value pair for the rank, and a key-value pair for the value. So we have the string rank here, and then the actual rank variable, the string value, and the actual value variable. Before we are printing the rank variable and the value variable, but let's update this code so we're actually getting the rank and value from the rank dictionary right here. So I'm going to copy that, and then I just pasted that, but now I'm going to use bracket notation, and so I'll put 2 brackets, but then I also have to surround this in quotation marks. And then I'm going to put the rank dictionary, the brackets, and then the quotation marks because we're accessing that key there. And then I can just run the program, and it's still doing the same thing as before, just a lot more complicated as far as the code goes. But it's going to be good to have more complicated code, as our program is going to become more complicated as we go. So when writing a program, there are many ways to do almost everything. Now we're going to refactor the code to get the value of each rank without using an if statement. Instead, we'll store both the rank name and value in the ranks list using dictionaries. So let's delete all the lines of code after where it says shuffle. So here, I know we typed in a lot of stuff there, but it was just kind of to practice, and now we're going to practice a different method of doing this. So now let's create a new card variable, a new variable called card at the end, and let's assign to the card variable a single card that will deal from the deck, but we'll make sure that card is not in a list. So this is a little tricky. I'm going to do deal, and I'll deal 1 card, but now I have to get the first item. So this is going to deal 1 card, but the 1 card it's going to deal is going to be in a list. So I want to get the first item in the list, which is going to be the only item in the list. So I have to put this 0 in brackets here to get that card out of a list before it goes into the card variable. Now we're going to update the ranks list. So here's the ranks list. Each element of the list should now be a dictionary. when lists or list elements are long, it's common to put each element on its own line. So we're going to put each element on its own line, and each element is going to have the rank and the value. So for instance, it will be rank A, value 11. Rank 2, value 2. So it's going to look like this. Now I'm actually going to zoom out just a little bit, and we have all these, there are all these ranks, and each one in this list is a dictionary. Each element in the list is a dictionary. Okay, now that this is updated, let's go down and just print a card so we can see now that we've updated that ranks list. So print card. Okay, so this is what it's going to look like coming from our list. So we got the suit, and then we have the rank that's also going to have the value here, the rank and the value. We can see every time we click it, we get a random item. Now let's update the code. So instead of printing the whole card, we just print the value. So in this example, the value is 2. So we just want to print this 2, just that value. So how can we update this? See if you can figure out how to update this line so it only prints just the value number there. So first of all, we have to see that we're in a list, and we need, so this is the first element of the list. This is the second element. So we have to start by getting the second element of the list, which is index 1. And then we have an object here, or a dictionary, I mean, and we need to get, so here we have this key value pair, so we need the value at that key. So to get the value of that key, we are going to put more brackets, and I'm going to put value, the key of value. So now that should work. Let's try it. Okay, 9, 7. See, every time it's going to just give us the value of the card. Now we'll start defining classes that will be used in order to separate out different aspects of the game. So classes, you may remember, provide a way of bundling data and functionality together. Creating a new class creates a new type of object, allowing new instances of that type to be made. An object can contain a number of functions, which we call methods, as well as data that is used by those functions, called attributes. So we're going to use classes to model 3 parts of the game: a card, a deck, and a hand. So far, we've mainly worked on the elements of the deck class. So right after this import statement at the top, we're going to make a class called deck. And we're going to put everything that we've written so far in that class. So we're just going to do class deck colon. Okay, now we just highlight everything here, and then I'm going to press tab to put everything in the class of deck, because everything's indented a little bit. And then these last few lines of code we don't need, so I'll just delete those. Those are just for testing out. A class is like a template. You can use that class to create an instance of the class called an object. Then you can use the instance. Each instance keeps track of its own state, so you can update an instance created from a class, and it won't impact other objects created from the same class. Soon you'll see an example of all this to make it easier to understand. But first, let's prepare a class to create an instance from it. When you create an instance of a class, Python automatically calls a function, also called a method, in the class named init. Remember, we already discussed this earlier in the course. So the contents of this init method should be code that is run one time to initialize the instance. So at the beginning of our class, let's create this init function. So we'll do def underscore underscore init underscore underscore. And if you remember from before, we always have to pass in self to all of these functions in a class, because then it gets, a self is referring to the instance of the class that we've developed. Now we're going to indent all the code that's not part of the shuffle or deal function, so the code will be part of this new function. So I'm just going to highlight all of this here, including the suits here, and then just press tab. So like I said, we just added self in here. You should always, all the methods in a class, or all the functions should have self. Anything inside the parentheses, remember, is called an argument. They're variables passed in from the caller to the functions. As I said, all functions in a class should receive self as an argument, and self represents the instance of the class. By using the self keyword, the function can access the attributes and methods of the class. So let's make sure to add self as the first item in the parentheses of the other functions. So we are going to add self here, and then see how we already have number here, but we're going to add self at the beginning, and we can still call this function with just a single number, but it's going to also get a reference to the instance here. Now I want you to notice that the cards here is underlined in red. So before it wasn't. Before we made this into a class, we could just access this cards variable, but now we cannot. So let's fix that. Inside a class, in order to access a variable in multiple functions, also called methods, the variable has to start with self dot. So we're going to change all instances of cards in every function to self.cards, starting with this. So self.cards. Now this is going to make it so we can access it in other places. And then we'll change this to self.cards. And then this is self.cards. And then self.cards. So now this will be a variable that's specifically associated with the instance of the deck that's created, and then we can access it in all of these other methods. Okay, we can now create an instance, also called an object, of the deck class. So at the very end of the code, let's create a variable called deck1 and make it an instance of the deck class. So I have to make sure I'm not indented at all, and I'll do deck1 equals deck. There we go. Now, since we created cards with self.cards, we can access that. We can access cards from the instance of the class. So let's just print out the cards from our deck1. So do print deck1.cards. And we can try that out. Now you can see the list of all of these cards. It has the suit and the rank and the value for each card. So underneath where we created deck 1, let's create deck 2. We'll create another instance of another deck. So now we can call methods on these instances. And you see some of the methods we have. We have shuffle and deal. So on deck 2, right after we create the deck 2, let's shuffle the deck. So deck2.shuffle. And then I have to make sure to put the parentheses at the end here. Right after we print deck 1, let's print deck 2, or the cards of deck 2. So I'm going to copy that, and then we'll print deck 2 cards. So now we should see that the deck 1 cards are not shuffled, and the deck 2 cards are shuffled. So let me move this over here. I'm going to run the program, and let's see if we can see where deck 1. So here's deck 1, and we can see how it's all diamonds, 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 all the diamonds are in a row because it's unshuffled. But then if we go into deck 2, we can see we have diamonds, clubs, spades, diamonds, hearts. So these are shuffled in deck 2. They are shuffled. Okay, the deck works. Now let's add safeguards to prevent errors. Every time the deal function is called, a card is removed from the cards list. You can only remove a card if there are cards to remove. So before the program tries to pop a card off self.cards, it should check if the length of self.cards is greater than 0. Remember, you can get the number of items in a list with length. So see if you can figure that out on your own. And then I'm about to show you how it's done. So when it's going to deal here, right as we're dealing, we're going to add an if statement here. So if the length of self.cards is greater than 0, and we don't need this parentheses here. So if the length of self.cards is greater than 0, then we will do this. We'll pop up a card and add it to the cards dealt. If not, we just won't do anything, and then we'll return cards dealt, which could be an empty array if there were no cards on the deck. And now let's add something to the shuffle function. A deck with only one card does not need to be shuffled. So let's add the appropriate if statement to the shuffle function. So we'll do if the length of self.cards is greater than 1, then we will shuffle. And then I'll make sure to put the colon there. Okay. Since a card is a separate concept than a deck, next we'll make a card class. So let's create a card class with an init function, and in that init function, we'll set self.suit to equals hearts. So hopefully you already tried this. I'm going to do class card, and then I will do def init. And then after the suit, we'll do self.rank and set it to A. So currently, anytime a card is created, it will be an ace of hearts. Let's refactor the code so the suit and rank are specified when a card object is constructed. So the init method can take additional parameters besides self that are passed into it as the object is constructed. So we'll update it to take suit and rank. Now we'll create a special method that's underscore underscore str underscore underscore. When a class has this specific method, it's called when print is invoked on an object from the class. So we want to make it so when we print an object from the card class, it will print something like 10 of hearts or 3 of clubs or something like that. So we don't do print here, we do return. It's going to return this to the print statement. It's going to return self.rank, and then we have to get the rank, and we do plus, and then of, we have to put a string there, plus self.suit. So now it's going to return the rank, which is like 2 or A of, and then the suit, which is one of these. So let's just try it out real quick. I'm going to go to the bottom. We don't need any of these to test because we're testing something completely different now. So do card1 equals card. I'm going to create a card and I have to pass in. Remember, I have to first pass in the suit. So how about hearts? And then I have to pass in the rank. But we want to make it look like these ranks. So I'm just going to copy one of these here. And then after we create the card, I can just print card1. Let me clear this, and then I'll just run that. J of hearts. See, it got the J of hearts. And feel free to add a few more cards like this and test out a few more if you want. Okay, now we're going to refactor this slightly. You remember way toward the beginning of this course we talked about F strings. So F strings allow us to put variables right within a string. Do you remember how to do that? Let's see if you can update this to use an F string. So first, we're going to create a new string, but we're going to start with the letter F. And then inside this string, we put curly braces around the Python code, and we don't need these other strings here. So now we put another curly brace, and then an ending string here. Okay, it's still showing these red squiggly lines because if I have a double quote around the strings, then anytime other quotes are in the middle, I have to put a different type of quote. So we're going to use single quotes. Okay, so now we can make this a whole string, but we use the brackets to put the variables right within the string. So now we've updated that to use an F string. So currently in the deck class, the last line of this init method appends a list as an item to the cards list. Instead of appending suit, rank, we'll create and append an instance of the card class. Then afterwards, when a deck is created, it's filled with cards. So it's just like this. We're just going to delete that. I'll put card, and then I'll pass in a suit and a rank. So now we're passing in card instances. So we're done with the deck and card classes, and we created them in such a way that they could basically be used for any card game. Now let's make a hand class. This will represent a hand in the game of blackjack. So create a hand class and add an init method and initialize a variable called self.cards that is set to an empty list. So let's go down here, and we can also get rid of all this test code here. So the new class is called hand deck. And we'll also make the hand keep track of the value of the hand. So self.value, we'll start it at 0. In this blackjack game, there will be a human-controlled player and a program-controlled dealer. So let's add a dealer parameter in the init constructor method of the hand class, and then when the hand class is created, dealer should be set to true or false to keep track of what type of hand it is. So I'll pass in the parameter dealer, and then we just have to create a variable and called dealer and set it to dealer. So self.dealer equals dealer. If you remember from before, function parameters can have default values. So we want to make it so the default value of dealer is false. So then if we create a hand and we don't set the dealer value, it will automatically be false. And I'm just going to take out these spaces here to make it smaller here. So now a hand can be created. Let's give it some functionality. We'll add an add card method, and the method should take a card list as a parameter. And then we need to add that card list to the cards. So we can use the extend function, the extend method, to append each item in card list onto the cards list. So it's just going to look like this: extend, and then we pass in card list. Now let's just add some code to test out what we have so far. So let's create a deck, and then we will shuffle the deck, deck.shuffle. Now we'll create a hand. Now we can add cards to the hand, so hand.add card, and we will deck.deal. We'll deal 2 cards into the hand, and then we'll just print hand.cards. Okay, so this is how it printed out. I was expecting this to look a little different because of this function. It should print like that. But I think the reason is because this is a list. So it's printing a list, not an individual card. So let's change this to print an individual card. I'll print the first card. So put 0 in there. I'll try it again. 9 of diamonds. And then we can also print the next card. 3 of hearts. And then we can also print both cards if we just copy that and do hand.cards 0, hand.cards 1. Okay, Ace of Hearts and 9 of Spades. So those are the 2 cards that were dealt to the hand. Now we'll go back to the hand class and we'll add the ability to calculate the value of a hand. So let's add a method called calculateValue, and inside the method we'll set self.value to 0. Now we'll take this one step at a time. First, let's make a for loop that's going to go through every single card, and inside the for loop, we'll just set the value of the card to a variable called card_value. So I'll do for card in self.cards. Okay, so we're not doing anything with that yet, but we're going to in a second here. Now we want to make sure that this is an integer, so let's convert that to an integer. If you remember, you just use int and then put it in int, and then inside the parentheses we put this value. Now just getting the card value for each card is not enough. Something must be done with the variable. So let's add that value to self.value. So we'll do self.value, And then if you remember from before, we can use the plus equals to add that to the current value. So we'll do card value. So as you may know, in blackjack, an ace can have the value of either 11 or 1, depending on what is better for the player. So there's a few ways to implement that in code. So we're going to do one way that's relatively simple. First, we'll check if the hand has an ace. So let's first create a variable that will store whether the hand has an ace. So it'll just be called has underscore ace. We'll set it to false, and we'll put it right under here. So we'll do has ace, and we'll set to false. And since we're only going to be using has ace within this method, we don't need to use self.hasAce because we're only using it here. And now, when we're going through the list of cards, let's check if the rank of a card is an ace, and then set hasAce equals true. So I'll do if card.rank, the rank is going to be equal, double equal sign, if it equals ace. After this entire for loop, we're going to check if the card has an ace and if the value is over 21. If so, then we'll just subtract 10 from the value, because that will be the same as setting the ace to equal 1 instead of 11. So we'll just do if has ace and self.value is greater than 21. Do self.value minus equals 10. Okay, and look at this. This is something I don't think I've discussed yet. You could say if has ace equals true and self.value is greater than 21. But you can also, it's like a shorthand. You don't have to say if has ace equals true, if has ace, because has ace is just going to equal true or false. So you can just say if has ace. So that's just the same as saying if true or if false. And so we're seeing if both of these evaluate to true, then we will subtract 10 from the value. Okay, now we'll just add another method to get the value of a hand called getValue, and the function will just return self.value. So we're going to make sure that we're indented correctly and do def get value return self.value. And then I have to make sure I put the parentheses here. And then I have to remember to put self. Since this is a self.value, we could call down here, like we could call hand.value to get the value, but it's generally better to make a function to return the value. So I can do get value. That way there may be some extra code you want to run in there. Like depending on different conditions, you may want to modify the value before you return it. So it's best practice to create a method that will get a value like this for you. So currently this value that's returned could be incorrect, because if someone's going to get the value has to be calculated correctly first, and like checking for aces and other things. So let's calculate the value before we return the value. So I'm going to do self.calculate value. So this is something that I think is new, where to call calculate value from within this, we're going to have to call self.calculate value, and self will refer to the instance that we're working with. So we're calling the calculate value on the instance that is the hand instance, and we're getting the value, and then we're returning the value. Okay, let's create another method called isBlackjack, and it'll return true if there's a blackjack and false otherwise. So it's a blackjack if the value is 21. So I'm going to do def get is, and put self here. Okay, so this is going to evaluate to either true or false, and return true or false, depending on whether there's a blackjack. Now we'll create the final method in the hand class that will display information about the hand. So let's create a method called display. To start with, we'll just print your hand. Okay, now let's do a quick refactor. Instead of saying your hand, it should either say dealer's hand or your hand, depending on whether self.dealer is true or not. So we're going to do this all in one line. We're going to use a few things that we learned about earlier, including ternary operators, f-strings, and going between double quotes and single quotes, and then one other new thing. We are going to make this into an f-string, and then we are going to be using actually single quotes and double quotes within this f-string. So if you want to use single quotes and double quotes within a string, then you can surround it with a triple single quote. So I'm going to delete this quote and just do 3 single quotes, and then delete this quote and do 3 single quotes. And so we got the double quote, single quote, and now this is a triple quote. So now we can use the double quote and single quotes within this string. So I'm just going to delete your right here, and we are going to put a ternary operator to see if it's going to say dealer's or yours, either dealer's hand or your hand. So to do some code, I'm going to have to put these curly braces here. And then to do this ternary operator, we're going to put dealer. And now here, so here's the double quote and here's the single quote. So dealers, it will return dealers if self.dealer. So basically, if self.dealer equals true, so return dealers if self.dealer, else will return your. Okay, that's the line. So it's going to be dealer's hand or your hand. And next, we will add a for loop that will print out each of the cards. So for card in self.cards, print card. And then finally, if the player is not the dealer, it should print value and then a colon and then print the value of the cards. So to do this, we can actually use the not operator. So if not self.dealer, then we will print, and we'll print value, and then I can just put a comma to print 2 different items. So the string, and then we'll print self.getValue. And it's gonna, when you put a comma in 2 different things, it's gonna put a space in between. And then finally, we'll just add a print statement that will print a blank line. Okay, let's test this out by, instead of printing this, we are gonna print hand.display. See if this all works how we thought it was going to work. So your hand, K of spades, 2 of spades, value is 12. So it's actually calculating that correctly because that's 10 plus 2 is 12. And then it's going to print none, which indicates that we did something wrong, which is that we did not need to print this because hand.display already prints. So now I'll just call hand.display. Okay, so now it doesn't put none, or it doesn't put none at the end. So that looks right. Okay, when you're playing blackjack, you don't get to see everyone else's cards. So we're going to update this. So when the dealer's cards are printed during the game, only the second one should display. The first card should display as hidden. So in this for loop, when we're displaying the cards, we're going to need to get access to the card index, since that will determine which to display, since we're only going to display the second card. So let's start by updating this for loop so we can get access to both the card and the card index. We briefly touched on this earlier in the course. We're going to be using the enumerate function. So when I say for card in, and now I'm going to type in enumerate, and then I'm going to pass in self.cards, and this is going to return the index and the card for each card. So I'm going to type in index, comma, And so we're getting the index and the card for all the items in self.cards. And so now we just have to update what's in the for loop to print hidden if it's the first card and it's a dealer. So we'll do if index equals 0 and self.dealer, then we will print hidden. And then we can use an else. Any other time, and let's make sure this lines up correctly, any other time we will print the card. So what we did wrong here is this should be double equal sign. I almost did the main mistake. You always have to watch out. Never use a single equal sign when you're checking equality, because that's the single equal sign is the assignment operator. So if index equals 0 and self, and it is the dealer, then we'll print hidden. So in our version of the game, at the end of the game, all the dealer's cards will be shown, so you can see what the dealer had. So to do that, we're going to create a new parameter in this display method, and it's going to be called show all dealer cards with underscores for spaces. And we're going to set the default value to false. Show all dealer cards, and when the default value is going to be false. Now we'll add it to this if statement. So we'll add another and not show all dealer cards. So it's going to be hidden if we're not showing all the dealer cards. But if we are showing all the dealer cards, then this whole if statement will be false, so we'll just print the card. And there's going to be one other scenario where we're not going to print hidden. If there's a blackjack, then the game is over. The person with the blackjack is just going to win, and then we'll just print all the cards. So we're going to add that to this long if statement here. So we'll say and not is blackjack, and it should be self dot is blackjack to be able to call this method here. And since this is such a long line, it's always going to go to this next line, we can do this special thing. We can add a slash here and then just go to the next line. So this slash, or it's a backslash, this backslash will indicate that the line continues on the following line. Okay, we're done creating the hand class. So we'll delete everything that we were using for testing before. Okay, it's time to code the final and longest class that runs the game. So what I want you to do is create a class called game, and inside the class create a method called play, and inside the method create a variable called game number with the underscore for the space, and set that to 0. So class game, and then we'll create another variable games to play and set that to 0. Now we're going to set games to play to be whatever the user inputs after they're asked, how many games do you want to play? So you may remember how to do input from before. So we just do input. Now we want to make sure the games to play is an int. So we just need to convert this to an int. Okay, now let's test things so far. So at the end, I will put g equals game. I'm going to create a new game, and then g.play. Okay, let's test this. How many games do you want to play? 5. Okay, well, it's not going to play the games yet. We still have to create that. So there is a potential for an error here. If I do this again and I just put how many games, I put U or some letter, we're going to get an error. So basically, anytime someone puts something that's not a number is going to be an error. So let's create a try except block to handle the exception. And if they put something that's not a number, we'll print you must enter a number. So let me arrange this, and we've already learned a little bit about try except blocks. I'm going to put try, and it's going to try this. And then if that doesn't work, if there's an exception, it will print you must enter a number. So currently the user gets only one chance to input a correct value. Let's make the program keep asking the user for a value until the user enters a number. This can be done with a while loop. The while loop just keeps looping while something is true. So keep looping until the user enters a number by putting the entire try-catch block into a while loop that keeps looping while the game's to play is less than or equal to 0. Oh, and I have to make sure I spell while correctly. Okay, now let's create the main game loop. This is a new loop that will loop one time per game played. It should loop while game number is less than games to play, and the first line of the loop should increment the game number by 1. Inside the loop, we'll create a deck object and a deck variable and shuffle the deck. Now we'll create a variable called player hand and set it to a hand object. And then we'll create a variable called dealer hand and set it to a hand object, but this time we'll make sure to specify that dealer equals true. Okay, this next part will be a little more complicated. We'll create a for loop that loops 2 times, and each iteration should add a card to the player's hand that is dealt from the deck and add a card to the dealer's hand that is also dealt from the deck. Okay, we've just dealt 2 cards to each player. Now information is going to be printed to the console for each game. So let's start by printing an empty line. Now we'll print an asterisk 30 times to make a divider. There's a trick to printing something a lot of times, so I can put an asterisk in quotation marks and then just do times 30. So it's going to print it 30 times. Now we'll print the current game number out of the total number of games. So it'll be something like game 4 of 10. And we'll use an F string. And then we'll just print 30 more asterisks. Now we'll display the player's hand. And then the dealer's hand. At this point in the game, someone could already have won if they got a blackjack. The code should check if there's a winner. Let's put the code to check if there's a winner in a separate method of the game class. So create a method called checkWinner. For now, the method should just return false. And just make sure everything's indented correctly. This should be less indented than the previous line here. The checkWinner function should take the player hand and dealer hand as arguments. Now, before this return statement, we're going to check if player hand.getValue is greater than 21. If so, we'll print you busted, dealer wins, and then return true. And remember, once the program gets to a return statement, none of the following statements in the block are run. Now we'll use a few elif statements to check for various other conditions. So we'll add an elif statement to see if the dealer got over 21, and then we'll print dealer busted, you win, and then return true. Oh, and I just copied all this, but this should be an elif, not if. And then we'll add an elif statement to check if both players have a blackjack, and then we'll print both players have a blackjack, tie, and then return true. And then we'll add an elif statement to check if player hand has a blackjack. And then we'll print, you have blackjack, you win, and then return true. And then we'll check if the dealer hand has a blackjack, and then say dealer has blackjack, dealer wins, and return true. Okay, we're done with all the hand win conditions, but the game can also end if both players choose not to get more cards. So we're going to add a new argument to the checkWinner method with a default value. It's going to be game over equals false. So we'll add game over equals false. If it's true, that means both players have chosen not to get more cards. Now we'll use the new argument. The string of if and elif statements should only be run if it's not a game over. And we'll make sure the line return false is not in the if statement. So here we'll say if not game over. And then I'll just select all these and put them in here. So if game over is true, we'll check if the player hand's value is more than the dealer hand's value, and if so, we'll print you win. So we can do this with an else here. Else if player, and then we'll do an elif for if it's a tie. So this is an elif, and we'll say if these are equal to each other, and we'll print tie. And then make sure we have the correct emoji for a tie. And then else, the dealer is 1. So we'll just do else. And then at the exact same level of indentation as the else we just added, we'll add return true. This will make the method return true if game over equals true. Now let's go back to the play method inside the while loop. And then we'll do an if statement, and we'll do if, and then we'll call the check winner function with the player hand and the dealer hand. So let's go back up here. If self.check winner, and then we'll enter the player hand and the dealer hand. So if this is true, that means we should go on to the next game. To do that, we do continue. So remember, continue is going to just go to the next iteration of the loop, and the loop we're on is this loop. So when we go to the next iteration, we start a new game. At this point in the game, the player will be able to choose hit or stand. So inside the while loop, but not inside the if statement we just added, we'll create a variable called choice and set it to be an empty string. The player should be able to keep choosing until the value of their hand is over 21. So right under the choice variable, we'll add a while loop that loops while player hand's value is less than 21. And inside the loop, we'll add a line to get the choice. That's either going to be hit or stand. And then we'll just add this to convert whatever the answer is, whatever the user put in, we are going to convert it to lowercase. The while loop we just added should also stop if the user's choice is stand or S. So we'll update the line that starts the while loop to also stop if the choice isn't S or stand. So I'll just do and choice not in, and there's a few ways to do it, but this is kind of a new way that I'm just showing you here. So we are checking if choice is not in this list, and inside the list we have two elements, S or stand. So if choice is not in that, if the choice is not S or stand, then we'll continue the loop. And then after the input, we'll print an empty line. Also, we want the program to keep asking the user for a choice until the user enters a valid choice. The valid choices are H, S, hit, and stand. So right after the last print statement, at the same indentation, we'll add a while loop that will keep looping until the user enters a valid choice. And inside that while loop, we'll ask for input again, but we'll specify it can be H or S as well. So this is going to look very similar to this line, but it's going to kind of clarify things just a little bit. And then we'll print another empty line. The last while loop, we checked if choice was not in a list. Outside of the recently added while loop, but inside the loop we just added before that one, we'll add an if statement to check if choice is in the list hit or H, and if so, we'll add a card to the player's hand that is dealt from the deck. And then right below that, we'll display the player's hand. Outside all of the while loops about the player making a choice, we'll check for a winner. We'll use the same if statement and continue statement that we used last time we checked for a winner. So I'll just copy this, and then we have to make sure it's lined up correctly. Okay, so this is outside of this while loop. So after this is all done, we check for a winner. Let's just add an empty line there to make it more clear that the while loop is over. Now we'll store the value of the player's hand in a variable named player hand value with underscores for spaces. And we'll do the same thing with the dealer's hand. Remember, I could use the Command D or Control D to select two words at once and change them both at the same time. Okay, the dealer should keep drawing cards until dealer hand value is more than 17. So we'll make this happen with a while loop. And inside the loop, we'll make sure the dealer is dealt a card from the deck and that dealer hand value is updated. So you can try that yourself, but I'm just going to show you right now. While dealer hand value is less than 17, then we will do dealer hand dot add card. Okay, and after this while loop, we'll display the dealer's hand. And when we call the display method, we'll make sure to set show all dealer cards to true. And since it's the end of the game, that's why we're just showing all the cards. Now we'll check for a winner just like before. Then we'll print final results. Then we'll print your hand, colon, and then the player hand value. And then the dealer's hand. Now we'll call the check winner function one final time. But this time it should not be in an if statement. And we'll pass in the hands like before, but this time we'll add a third argument of true to indicate that the game is over. And at this point in the code, the game is over. So outside the outer while loop and in the play method, we'll add the final line of saying, "Thanks for playing." So it's going to be outside that while loop, and we'll put print. And just to demonstrate it, I use an escape character to add a new line. So this /in is going to add a new line and then do thanks for playing. And when I line this up with the while loop, I realize that this entire function should not be lined up with the while loop. Sometimes it gets tricky with figuring out the exact right indentation. So if I kind of go up straight up here, I should see that this should be lined up with this play function. So I'm going to come back down to this function. I'm going to copy this all, and I'm just going to do Shift Tab to indent it all one less. This happens sometimes when writing Python code. Sometimes the indentation can get all mixed up, but that should be correct now. And I think the red squiggly lines here on the return true are not a mistake in the code, but a mistake in the error checking, because it comes after that emoji and it doesn't know how to handle the emoji. But it's perfectly fine for code to have emojis. Okay, let's run the program and try it out. So I'll press play. How many games do I want to play? I'll do 3. So game of 1 of 3. So I can see I have 17. I don't know what the dealer has, but I'm going to S for stand. Okay, it's always good to test. So it says deal is missing one required positional argument. So let's go up to, it says line 139, so this can kind of help us know where to go. So let's go up to 139. And yeah, I want to deal a single card. So I'm going to deal one card here. And were there any other times I did use deal? I went to deal one card here. And yeah, I got the deal one up here. So I just think I just forgot the deal one in those places. So, thanks to these error messages, whenever you have a problem, make sure to read the error messages, and it can often give you a very good idea of what you need to do wrong, because it even says, deal is missing one required positional argument, the number. So that can really help figure out what's wrong with your code. So let's try that again. We'll do 3 games, and then this time I will hit, and I'm going to stand. Okay, so now we have another error. So it says 173, and I can already see this is spelled wrong. So let's go to 173 and make sure I spell that correctly. And make sure I spell that correctly. Okay, let's try again. How many games do you want to play? 3. I'm going to hit and hit. Okay, so the first game, you busted, dealer wins. And now we're on game number 2. I'll hit, and this time I will stand. Okay, dealer busted, you win. Now we're on game 3 of 3. And I will hit, and I will stand. And final results, your hand 20, dealer's hand 19, you win. Thanks for playing. We just completed this whole game.
Okay, we've reached the end of the course. So you've learned the basics of Python, and if you've been coding along, you've written 2 Python programs. Good luck on your programming journey. Thanks for watching, and remember, use your code for good.
Bye. 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 Bye.
Okay.